Welcome to AI Crush 2025. You are here on the developer track, and I'm really excited because we have such a phenomenal lineup today. And before we get started, I just want to say a quick thank you again to all of our partners who made this possible today. So check them out in the lobby if you haven't already. They'll have people around the event all day. So if you're trying to learn anything, just go ahead and check them out as well. Today's lineup is absolutely incredible. And I know we have Jesse in just a second, but I just wanted to take a minute so everyone can have a little look at the incredible lineup we have for today. I really don't think any talks are to be missed at all. But without wasting any more of your time, we know why you're here. It's not to see me. It is to see the talented speakers that we have on today. And here is our first speaker, Jesse. And he is going to be doing AI in just 2 lines, from a basic chat to agentic apps. Jesse, the stage is yours.
Today, I want to talk to you about something that's both incredibly powerful and surprisingly simple: how to build AI applications with just 2 lines of code. Seriously, here's the 2 lines of code. I guess the talk's over. Okay. Just kidding. We will go a little bit further than that. But before we do start, I want to say that if you're expecting some complex lecture about machine learning algorithms or neural networks, you are at the wrong talk. Maybe that will be in the next one, but that's not what we're going to do today. Instead, I want to share something that I think is much more exciting and practical for all of us as developers. I want to show you how easy it is to build AI into your applications. So who am I? I'm Jesse Hall. You might know me from my YouTube channel, CodeStacker, or from my work as a staff developer advocate at MongoDB. So I want to ask you this question. Do you think you could be an AI engineer? Think about that. Do you think you could be an AI engineer? Well, when I ask people this question, usually the answer is no. And when I ask them why, usually they say things like, well, I've never studied machine learning, or I don't know Python, or I'm not great at math, I don't know linear algebra, or I don't even have a computer science degree. Well, here's the thing. Those are all misconceptions about what AI engineering actually is. And AI engineering is dramatically different from machine learning engineering or data science. So let me tell you something. The truth is that you can be an AI engineer, because I don't have a computer science degree. I don't know Python that well. And I don't know the first thing about machine learning models, but I am an AI engineer. Here's a quote from Swix, Sean Wang, the author of Rise of the AI Engineer. And if you've never read this article, go Google it, The Rise of the AI Engineer. You really need to read it. But he says a wide range of AI tasks that used to take 5 years and a research team to accomplish now just require API docs and a spare afternoon. Isn't that really the case? And don't just take Sean's word for it. Here's another quote. In numbers, there's probably going to be significantly more AI engineers than there are ML engineers or LLM engineers. One can be quite successful in this role without ever training anything. Focus on that last part there. One can be quite successful in the role of an AI engineer without ever training anything. Now, that's from Andrej Karpathy, the former director of AI at Tesla and from OpenAI. So let's look at this amazing diagram here, also from Swix. And if you look at where the API layer sits in this spectrum, on one side we have machine learning research and machine learning engineering, the people building and the actual models, training them. And then on the other side of the API layer, we have the AI engineer and the full stack engineer, people applying these models, implementing them to solve real problems. Now, I'm not sure where the majority of the audience here sits, but speaking from my personal perspective as a web developer, I sit on that right side of this diagram. And web developers consume APIs all of the time. And guess what? That's exactly what AI engineering is, consuming AI APIs to solve problems. Now, it is important to call out that this is not black and white. So there are aspects of the left side that can bleed into the right and vice versa. Now, of course, we have to understand how to use these APIs. There are many knobs that we can turn and tweak to customize things. But in the simplest of terms, it is just an API. And AI engineers, they really bridge the gap between ML engineering and product development. And they apply these pre-trained models and APIs to solve product challenges, focusing on integration rather than simply mathematical optimizations. So before we dive into the code, let's clarify what AI actually is. And there is a different types of AI. So there's rule-based AI. So think of video games that you might have played as a kid. For me, it was Galaga, Pac-Man, Mario Brothers. They followed predetermined rules programmed into them by developers. And this has been around for a very long time. And then there's predictive AI. Like when you're in Google Docs and it's trying to predict the next word, or on your phone's keyboard, these are statistic models that predict the next likely word. And then we have generative AI, and this is what's getting all of the hype now, models that can create novel content based on patterns that they have learned. And generative AI is exciting, but it has its limitations, doesn't it? AI can confidently make stuff up. It has no concept of truth. It hallucinates all of the time. It has, even the biggest models have limited memory, so the context windows are very important. And then the knowledge cutoff. Most models stop learning at a certain date, and they don't know what happened after that. And so there is a technique that solves all three of these problems, and that is called RAG, which stands for Retrieval Augmented Generation. And it's just a fancy term for something actually pretty simple. And you might hear this explained to you in other talks. They might take the entire talk to explain what RAG is, but this is the most simple explanation that you will ever see. So screenshot this if you haven't seen this before. So RAG means to retrieve some up-to-date information from an authoritative data source, and then add that information to your prompt to augment your prompt, and then let the AI generate a response to a user's query based on that extra information. That's all it is. And that is, it's powerful because it gives the AI access to current, accurate information that it wouldn't otherwise have. And so to make AI work effectively, we need a way to find the relevant information and to include it into our prompts. And that's where vector embeddings come in. So what are vector embeddings? Well, they're basically a way to convert words, images, video, audio into numbers that an AI can understand. But not just any numbers. These are special lists or arrays of numbers called vectors or vector embeddings that can capture semantic meaning. So a quick brown fox gets transformed into an array of numbers. A common number of dimensions is 1,536 dimensions. Think about that. So in a 3D graph, you have an x-axis, a y-axis, and a z-axis. But this is much more than just 3 dimensions. This is 1,536 dimensions, which can contain significantly much more data. Now, just a side note, this could be a whole nother talk, but when it comes to dimensions for these vector embeddings, less is more. So just keep that in the back of your mind. Let's move on, and let's think of vectors as coordinates in space. So if I say the words like dog, cat, pet, these words should all land near each other in this mathematical space. Words like car, train, bus, airplane, those should land somewhere else, and so on. And so what's fascinating about this approach is that we're converting semantic meaning, actual understanding, into mathematical positions. And when an embedding model processes text, it's essentially plotting points in this high-dimensional space in a way where similar concepts could be clustered together. And this is where I stop. I have no idea how these calculations are made, and frankly, I don't care. I'm not a machine learning engineer. I'm an AI engineer. Remember, an AI is just another API. Understanding the core concepts, though, is what's important. So now it's demo time. Let's take a look at see some of this in action. So I'm going to walk you through a set of examples that demonstrates how easy it is to build AI into your applications. And we're going to use the Vercel AI SDK. This SDK makes it incredibly easy to get started. So let's start with the most basic example, text generation. So I'm going to type into this prompt, list all Star Wars movies by release date. Okay, so the LLM, the language model should know this information. Let's click generate, and then we will wait. It says generating here. And then we get our information here from the LLM. And this is as simple as it gets. We have a form here where we can type in a prompt and we submit it and we get the AI generated response. So if we go back up here, behind the scenes, here is the code that it is implementing. Starting with the back end here, we're using the generate text function from AI. This is from the Vercel AI SDK. We're also bringing in OpenAI from the AI SDK as well. And then if we scroll down, we have our generate text where we're passing in the model, the prompt, and then any other arguments that we want to add to it. And then we're just returning the response right here. And then on the front end, all we're doing is fetching from this generate API. So the magic here is that all of the complexity of calling the AI API, handling the response, and dealing with errors is abstracted away. So it's literally just an API call. So let's move on to this next example here, streaming. So let's do the same thing. List all of the Star Wars movies by release date. And notice what happens this time when I click generate text. It streams in. So instead of waiting for the entire response, streaming shows the text as it's being generated. So this creates much more engaging user experiences, of course. So let's take a look at the code here. Again, let's start with the back end. This time we are using the stream text function from AI. And then if we come down, we're just calling stream text, passing it the model and the prompt again, any other parameters that we want, and then returning this data stream. Now on the front end, we are using use completion from the AI SDK. So the AI SDK is broken down into back-end functions and front-end UI functions. This use completion hook handles all of our form actions, including input management, form submission, and completion results. So all we have to do is plug those directly into the form. So we have our handle submit, our input, handle input change, is loading. All of that is coming in here from this use completion hook. So again, very little code. The AI SDK handles all of this streaming complexity for you. Let's move on over here to Text Summarizer. So this example is a little bit more practical. You can paste in a long document, article, or any text, and AI will create a concise summary for you. So here we can insert some example text, and then let's create the summarized text, and that streams in. Much less text than we started with, of course. So let's look at the code for this. So on the front end, again, we're using that use completion hook. And on the back end, we are using stream text. That's exactly what we used for the text streaming example. The only difference here is if we scroll down, we're including a prompt here, summarize the following text in a concise, informative manner, and then giving it the actual prompt here. So this example shows how the same pattern can be applied to different use cases. The code is almost identical to our streaming example, but the application is completely different. Another example here is system prompt. This one's pretty funny. We're going to include this system prompt. You are a pirate. Always respond in a pirate dialect and use nautical analogies. That's my best pirate voice. What are the 3 largest countries in the land by land area is our user query. So we're going to generate the default behavior and then the behavior with our system prompt. So let's generate that. And here we go. This is just pretty bland and boring. And then here is in pirate voice. Let's take a look at something a little bit more advanced under structured output. So instead of just free-form text, we can ask the model to return data in a specific format like JSON. And so in this example, we show a couple of examples. So we have product extraction and sentiment analysis. So we have in here this product description, and we want to extract some key information from this. So let's go ahead and click extract product data. And we can see that it's breaking it down into some structured data. It's taking this product description and it's converting it into a structure that we can use to fill in specific fields here under this product data. So we're pulling the name out, the price out, category, rating, whether it's in stock, and the features directly from that. So let's take a look at the code for these. So on the front end, we are using use object. So unlike generate text, which returns a string, use object returns data that matches a specified schema. So we define our schema using Zod. So if we come down here to the API route, you'll see that we're using Zod here and defining this product schema, and we're describing it. And the backend uses this schema to instruct the model to output the data in this correct format. And then it validates the response against the schema to ensure that it is valid before it returns it. So again, this is so much code that you would have to write on your own, boilerplate code that the AI SDK is completely abstracting for you. One feature that I thought was extremely nice in the AI SDK is testing. So can you imagine having to test all of your API endpoints and all of the expense that could cost you in just the testing phase alone, right? So this example shows us how we can use mock models for testing different types of AI interactions. So we can use the use chat hook. And this is an example of a mock configuration. And so we'll go ahead and send a message. Let's just say hi, send, and we get this mock response back. We can do the same thing with use completion and same thing with use object. And then here is an example test using vtest. So here we're using the use chat hook here, and we're using this mock language model v1 from the AI SDK. So this lets us create deterministic mock models for testing. So you can configure these models to return specific responses, simulate errors, or even track token usage, all without making a real API call. And it's not all about text. Let's take a look at the alt image text generator. This demo lets you upload an image or use a random image, and then AI analyzes it and generates an appropriate alt text description for it. So let's go ahead and just get a random image. Nice, and then generate the alt text for this image. So we want to keep our character count under 125. We've instructed the model to do that. So we're making sure that this is a short, concise, descriptive description of the image. So let's take a look at the code. So on the front end here, we are just using fetch and just fetching from that API endpoint. And we are also passing it this prompt, generate a concise alt text for this image. And then in the API route, we are using generate text from AI. So we're passing in the image source and then the prompt, and pretty simple. And then in the messages, we are adding in the content. And so we have a content type of image here for this specific model that we're using. Not all models can be passed images, but in GPT-4o we can. So we're passing in that image and then the text with the prompt. And now not all AI has to be run in the cloud. The AI SDK also supports local models too. So we'll go over to the local model here, and we do need to make sure that we are running a local model. And we can use any model that is OpenAI compatible, like Ollama or LM Studio or any other self-hosted models that are OpenAI compatible. So we just pass in the base URL of our local model, the model name that we're running, and then ask it to do something. And there we go. We're running all of this locally. So let's take a look at the code. On the front end, again, using use completion. So on the back end, we're using create OpenAI compatible from the AI SDK and generate text and stream text, and then just using that local provider. Very simple. So it's extremely beneficial when developers want to work offline or they have privacy concerns or need to use specialized models that aren't available through cloud providers. Now here's where things get really, really cool is chat history. So let's go ahead and ask it a question. Let's say, what is my favorite color? And it's going to say, I don't know. I don't know what your favorite color is. So I'm going to say, my favorite color is black. Cool. Now I'll ask it, what is my favorite color? And it says my favorite color is black this time. So it remembered. So chat interfaces are more complex than simple text generation because they need to maintain a history of the conversation. And the AI SDK makes this very easy with dedicated hooks for React. So for example, this one here, let's go look at the code. We are using use chat. So use chat, we have our messages, our entire messages array, our input, handle change, all the other stuff that we're used to as well. So this is all built into the Vercel AI SDK. But what happens when you refresh the page? Well, of course, it forgets. So how do we create persistent memory? So let's go over to our chat persistence example. In this example, we can create multiple chats and keep track of the entire history. So let's create a new chat. And let's say, what is MongoDB? And it goes through and answers my question. That's a very, very long-winded answer there. But then we can keep track of multiple conversations, delete them, and refer back to them. And it keeps track of the entire history. So let's take a look at some of the code here. So we're using use chat, and then we are using some server actions. So create chat, save chat, load chat, list chat, and delete chat. All of these are interacting with MongoDB. So we can call all of these from the front end here with our use chat. So on finish, we can go ahead and handle that save and so on. So in our server actions, we define our database name and collection. And then we have a function here to create a new chat, to save a chat, load a chat, list chat, delete a chat, and so on. And then if we go down to the actual API route, we're just using stream text. And as we send and receive messages, we save them to MongoDB. But again, so far, we've only been dealing with the native LLM models just out of the box. So remember, we talked about RAG from earlier. Let's see that in action next. So this example implements retrieval augmented generation using MongoDB's vector search. And it retrieves relevant information from a database and includes it in the prompt to the AI model. So the first thing that this does is it makes sure that we have vector search indexes set up. And it makes sure that we have documents in our database that we can use to answer these questions. So if we go down here and we say, what is the Vercel AI SDK? It's going to answer this from the information that we have in our database. So if we go over here and look at the code, see on the front end, we are using use chat. We have some server actions set up to create our vector index and our example documents. You can see that here in this server action implementation where we are using Voyage AI as our embedding model. We're setting up our vector index and then seeding documents if needed, if they're not there. So we have some documents here relating to MongoDB Atlas, vector search, and the Vercel AI SDK. And then we insert those to seed the database and generate embeddings along the way. And here is one of the most important function is find relevant documents. So this is the function that we call when we are looking for the correct documents using vector search. So we take the user's query and we create an embedding for their query so that we can compare this embedding with the embeddings that we already have in our database. So we tell it which collection to look at, and then we look for the relevant documents using vector search. So on the API route, very, very simple with a stream text where we're just sending and receiving messages to the AI. The only difference here is that we are getting the relevant docs from our find relevant documents server action, and then we're injecting that into our enhanced system prompt, adding more context before sending it to the LLM. So each of these examples kind of build upon the other. We've gone from very, very basic things and now into RAG implementations. So next we'll look at something much more advanced, and that gets us into agentic AI. So let's look at tools. So here we're going to ask it, what is the weather in New York? And also, can you calculate 2003 divided by 7? So we're asking it two completely different things. So if we run that, we'll see that users asking this question, and here's the assistant answering the question. But what did it do in order to get this information? Well, it actually ran two tools. So we have a tool called getWeather, which gets the weather from the location that was asked for, and then getWeather returns that result. And then we have another tool call, and there's a tool called Calculator, which is going to calculate this, and here's the result that it returned. So on the front end here, again, we're using use chat, and then in the API route, we're using generate text and tool. So in here, we can specify the different tools that we're going to define here. So we have our getWeather tool, and we're describing it, getWeather in a location. I'm using Zod to validate this and to describe it. And then in the execute, we have our function that will execute here, returning the specified parameters. We have another tool called Calculator, which calculates a math expression. And then here in our generate text, we are then going to pass in those tools, give it a max step so it doesn't just continuously go. And then on finish, return each one. So this pattern lets you extend AI capabilities with custom functionality, whether it's searching a database, calling external APIs, or performing calculations. The sky is really the limit here. And for our final example, let's look at a complete agentic application. We have a social media agent here. So we can pick which platform and then give it an article or something for it to create some social copy for. So let's go ahead and generate a social media post based on this article that's already in here. And so what it's doing here is it's going through each of these steps, drafting up the content, measuring the engagement, adding some hashtags, and then here is the final post. So here are the steps that it took. So it went through, and the first thing is it analyzed the article that we gave it. Maybe I should work on the CSS here, but we can still read this. So the second thing that it did was generated the actual post. It evaluated the post, giving it a score of 1 through 10, added some hashtags, and then sent over the final post. So let's take a look at the code here. All right, so on the front end, again, we're using use chat here. And then on the back end, again, we're defining our tools. We have our analyze article tool, which extracts key information. Then we have our generate a draft social media post, so generate the post tool, and so on. Then we create our data stream response and pass in those tools and allow it to go through each tool and then return the responses. So this example brings together several concepts that we've explored: structured output for generating formatted post content, tools for generating hashtags and checking character counts, RAG to pull in relevant information about the topic, and a chat interface for iterative refinement. So what have we learned today? Well, building AI applications doesn't require a PhD or even deep AI knowledge. It's about using the right tools. The Vercel AI SDK reduces complex AI implementation down to just a few lines of code. And by combining these simple primitives like text generation, tools, and RAG, you can build powerful AI agentic applications. Now, the key takeaway here is that AI development is becoming increasingly accessible. You don't need to be a machine learning expert to build powerful AI features. You just need to know how to use the right APIs and tools. So give the Vercel AI SDK alongside MongoDB a try in your next project. Thank you.
Before our next talk, I wanted to say a big thank you to SkillNet Ireland, who are our platinum sponsor for the event. Without the support of SkillNet Ireland, we couldn't have done this event for free today. So I'm really, really excited to have them involved in the event. The next speaker of the day is Tejas, and he is talking all about AI agents for the rest of us. Tejas, the stage is yours.
I'm Tejas Kumar, and I'm a developer relations engineer at DataStax, where I get to work on LangFlow, which is the easiest and most visual way to build AI agents. This talk is titled AI Agents for the Rest of Us, and the goal of this talk is really to democratize what AI agents are, how they work, what they mean, and most importantly, how you can build them yourself. AI agents is a term that is used a lot. And unfortunately, it means different things to different people. I was once at a conference and somebody did a talk about how they built AI agents. And this talk, instead of what I was expecting to be agents, was instead custom GPTs, which was a feature of ChatGPT where you can make custom GPTs and add knowledge to them. To me, that's not what agents mean. So together, we're going to understand what an agent actually is in terms of formal definitions. And this is not hype driven, this is think more academic. And then we'll look at what it takes to build one. To lean on the understanding of those more competent than I'm not going to go with like my definition of an agent, but instead we'll look at what Google says an agent is. And to do that, we'll reference their paper. This is a paper by Google titled Agents by Julia Wiesinger, Patrick Marlow, and Vladimir Vuskovic, published in September, of 2024. And this paper just outlines the definition of agents very well. It says this: the combination of reasoning, logic, and access to external information that are all connected to a generative AI model invokes the concept of an agent. I'll say that again. The combination of reasoning, logic, and access to external information that are all connected to a generative AI model invokes the concept of an agent. What does that mean? Well, an agent in this case is something that can reason and deduce logical outcomes while being connected to a language model and take actions or use tools on users' behalf. To understand this a little bit more, let's just think of the term agent. What is that? And then we don't need to think in terms of AI or machine learning or anything. We just let's think English. An agent. Well, an agent can be defined as an entity that takes logical action. An entity that takes logical action either on behalf of the self or the other. And by this definition, I am an agent. Me. I'm an agent, and with my agency, I'm giving you this talk. Does that make sense? With my agency, I'm giving you this talk. We all have agency, therefore, we are all agents. We are entities that are able to take logical actions on the behalf of ourselves and sometimes others. For example, if somebody is sick, you can give them water and help them drink, and this taking an action on their behalf. So that's, I think, very, very important to start here. And Google's AI definition of agent lines up with the English definition of agent very well. And this is why I think we have some synergy. Okay, but what does that entail? How do we experience and exercise agency throughout our day-to-day lives? Well, a lot of it is choice. For example, I'm choosing to do this talk. Thank you for having me, AI Crush. But also, it's logic. And sometimes some things are just more logical than others. What does that mean? Here's an example. If you ask me to do some very difficult math, if you ask me to multiply a matrix of prime numbers, it's illogical for me to try and do that in my head. That's what I mean by logic. Similarly, if you ask me to multiply 13 and 19 and 100 million and 6 and 4, it's still illogical for me to do this in my head. It's also illogical for me to try and work it out on paper. It just doesn't, like, logically, my logical with agency, my logical deduction says this isn't right. That's agency. The same logical reasoning with my agency would lead me to discover a tool that is available to me. Does this make sense? What is that tool? That tool is a calculator. And so if you ask me to do some impossible math that I can't do in my head or on paper, then my logical agentic reasoning will lead me to a tool, the calculator. And so I know, okay, this tool exists. I'm going to go use this tool. Does that make sense? So tool use is a part of agency. So it makes agents agents. So it makes us human agents. It makes AI agents agents. Okay, so tool use. But then let's explore this a little bit more. Say I get a calculator, and you ask me to multiply 13 and 37. What do I do? Well, my agency gives me. I get the tool. I've reasoned. Okay, I need this tool, but I have a calculator, and in and of itself, it's kind of useless. Now I need to use my. Stay with me. I need to use my language model. Let's consider that this is a part of my brain. I use my language model to generate inputs to the tool. Does that make sense? If we want to multiply 13 and 37, I need to use my language model to generate the inputs 13 and press the multiply sign, then generate the other input 37. So I need to do that. My language model generates the input arguments to the tool, to the function, calculate. You see where this is going. And then my agency hits the equals button. I call the function, and then the function returns me a value, 13 times 37. Let's actually do that. I'm going to pull up a calculator here. You can't see this because it's on my screen, but 13 times 37, the tool says back to me 481. That's the product. So now I know, and now I can my language model can synthesize and even tell you I just did the product of multiplying 1337 is 41. Does that make sense? This is all agency. This is natural, organic, biological, human agency. Language models or AI apps replicate this, and that's what AI agents are. It's when you can you can reason with logic, use tools, and execute actions on your behalf or the behalf of another. This is the definition of agent. I hope that makes sense. And this is very important to set the stage for the rest of our discussion. Okay, so let's now go back to this Google paper. The combination of reasoning, logic, and access to external information that are all connected to a generative AI model invokes the concept of an agent. I love it. It takes on a whole new meaning now. So we looked at reasoning and logic for me to decide that I need a calculator. Access to external information is the calculator, and all of this is connected to my language model in my brain. So we've looked at the human version. Let's look at the machine version. So if we scroll further in this paper, what is an agent? Well, here's a diagram. Picture is worth 1,000 words. This is what Google in their paper say is an agent. This is a human, this little blob. User sends a query to an agent runtime, and inside the agent runtime, you've got three parts. You've got an orchestration layer. This performs things like chain of thought reasoning and logic. You've got a model, that's a language model, similar to the one in my brain. And you've got tools. Tools are like the calculator and other things. And then you send a message to the runtime responds to you, and the loop is closed. I'd love to explore this a little bit more with an evolution of a popular AI technique called RAG. For those who aren't familiar with RAG, it stands for Retrieval Augmented Generation. It's when a language model doesn't have access to the latest information because the training date was sometime in the past, and you retrieve real-time context, like modern context, and you use it to augment or change the generated output of the language model. That's what retrieval augmented generation is. And it's been around for a very long time, and it's a very popular technique with AI applications. But it's changing in light of agents. And so what I'd like to do is just model that for you now. It's worth noting that RAG is easily seen everywhere. RAG, so for example, if we go to ChatGPT, you can actually see RAG. So let's go here and ask for weather in Berlin right now. And searching the web, that's RAG. So it's retrieving the weather information from the internet because it doesn't know it. And it's using that retrieved information to augment the generation, the output. So today is 61:42. I wanted Celsius, but whatever. You see that? So it retrieves because it doesn't know. That's RAG. Let's explore RAG in another way using a tool that I work on. It's called Langflow. Open Langflow here. Langflow, by the way, is free and open source. I'm running it locally. You can too. We have some content on that. If you want to know how you can do this, go on YouTube to Langflow here on YouTube, youtube.com/@Langflow. And there's content there. Drop a subscription. But if you come to Langflow, let's just add like a chat input. And of course, we need a chat output and a model. So let's do model. OpenAI. Perfect. Just like that. Okay. And now we're just going to connect chat input here. We're going to connect the chat output, And boom, we've got this. Let's just paste in an OpenAI API key and we should be good to go. So I'm gonna open the playground and I'm gonna say, what's the weather in Berlin? And I'm unable to provide real-time weather updates because we're just talking to a model. We need to make a RAG AI app. Okay, how can we do that? Well, let's look at how RAG actually works. So if we come back here, we need some more stuff. For example, we need URL, and we need to go get weather information. So I'm just gonna quickly, actually this needs to extend a little bit. So we don't just send the chat input directly, but we construct a prompt. RAG and prompt engineering go hand in hand. It's very, very important. Okay, so now we've got this type of stuff. The prompt is, given this information from the internet, we'll just do info here, answer the question, and we'll do question. Okay, so now what we can do is the question still comes from the chat input, but the info has to come from somewhere, and that can be some URL here. So let's go get weather in Berlin from the internet. Maybe BBC weather. The page needs to run without JavaScript. So I'm just going to quickly disable JavaScript and try again. This totally works without JavaScript. So let's go to this address and paste its data in info. So now we're going to retrieve this and then we're going to put in the prompt and we're going to answer the question. We'll send the prompt message here. Okay, so let's go back to the playground. And this is actually RAG. So what's the weather in Berlin? And previously it didn't know. It said I can't get real-time information. Now we are getting real-time information. The weather in Berlin includes sunny intervals with a gentle breeze. The high temperature is expected to be Celsius and Fahrenheit. You see that? That's RAG. That's actually RAG. And this is how RAG has been done for many, many years. By many, many, I mean 2, but AI just moves so fast. Let's look at how RAG is changing to accommodate AI agents. To do that, we're going to explore agentic RAG, where our agent, again, an agent is this orchestration layer, right? An agent is this runtime. So our agent will reason and deduce, okay, what's the best website to get weather information? What city, what, etc. It's just going to decide all this on its own. How can we build that? Well, again, let's use Langflow. And by the way, if you want to use Langflow and like Langflow, drop a follow on X, formerly Twitter, at Langflow_AI. That'd be helpful. So let's look at Langflow, and we'll do agentic RAG here. So I'm going to get rid of a lot of these things. We'll keep the chat inputs and outputs, but let's create an agent. Langflow just has agents just like this. So we'll do an agent. And the chat input can go to the input. The response can go to the chat output. Agents, as we looked at. So again, let's go back to that Google thing. The agent is a runtime. This is the orchestration layer. Langflow is the orchestration layer. The model will come from OpenAI or Anthropic, and tools we'll look at. So this is the orchestration layer, agent. It has a model connection with OpenAI. We'll paste the API key. But now we're missing tools. Well, let's see if there's a weather. Okay, there's no weather tool, but we can use the URL actually. So this URL component, we just looked at this, right, with RAG. It's the same component, except now I can turn on tool mode and I can use it as a tool to an agent. And the cool thing about this is I'm not giving a URL anymore. The agent will decide the URL. Look at that. So there's also actions you can do. I just want to get, I think maybe let's not get the data frame. We'll do the others. Okay, so now we have this agent using the tools. I'm not saying anything. I'm not doing prompt engineering because I don't need to write a prompt. The agent will figure it out on its own. Let's continue looking at this. So let's go to the playground. I'll send it the same prompt. What's the weather in Berlin? And now agentically, it will automatically decide which website to use, what URLs to call, what city to use, etc. I have the wrong API key. Whoops, I must have copied something. Let's get it again. So we'll try that. And we'll start a new conversation. What's the weather in Berlin? And now it's going to look at this. I currently don't have access to real-time weather data. Well, use your tools. Use your tools. And I don't have, use your URL tool to get the weather. Okay, now it's doing something. Accessing fetch content text. It's executing tools. It seems the URL could not access weather information here. So it tried weather.com, but it got a 404 because it generated it hallucinated the link. And this is very normal. This is part of the process. In fact, look at that. We do have this. So how can we do better? Well, let's go to our actions. And instead of these, we can rename our tools. We can say, let's actually get rid of this tool, and we can say fetch weather content from URL. We can literally say that's the name of our tool, and we can excuse me, we can then give a description. Use this tool to enter a URL and find weather information. Prefer BBC weather, because we know that one works, but you can leave the freedom up to it still. Cool. Let's try this again. Get what's the current weather in Berlin. We send that off. And now look at this. It just knows. Look at that. The current weather in Berlin, and it just know. And let's read this. It just knows BBC weather. That's incredible. You see that? This is also how we influence the agent. So ultimately, the agent still made the choice, but we made the tools accessible. For example, look, if I don't know the word calculator, and I don't know what a calculator is for as a human, I'm never going to go use it. It's the same thing. We renamed the tool a little bit, and we changed the description. If I don't know the description of a calculator, aka this is a tool used to do math, I'll never use it. So we changed does this make sense? I hope now you understand, wow, I can do that with agents. That's cool. Indeed, you can. Agents are very close to what agents are in English. And this is what we just looked at, is agentic RAG, which is the evolution to RAG. Finally, let's explore how we can use these agents anywhere through something called Model Context Protocol, and we'll wrap up there. So Langflow 1.4 supports Model Context Protocol, which is a way of sharing tools and agents with any application, Cursor, Claude Desktop, etc. Langflow has native support for this. So let's take a look at how this works. So again, let's go back to my projects, and you'll see I have a Google Assistant that can indeed, this is an agent that can actually like work with my Google stuff. And we have the one that I just made, which let's maybe rename this to weather agent. Discover the weather in cities. I don't know, something like this. Okay, save. And now, since I'm in a project called the startup project, every flow in a project becomes a tool on an MCP server. So this is our MCP server. So what I'm going to do is I'm just going to copy this configuration, lf my projects. This is given to me, of course, by Langflow, and go to a Model Context Protocol app like Claude Desktop. Okay, so Claude Desktop is going to open. This is Claude Desktop. Welcome. And I'm going to add my MCP server to this. So I go to Developer, Edit Config, and open the configuration file in VS Code. I'm just going to paste it right here, lf my projects. Okay, and now I'm going to restart Claude Desktop. And when I do, we will have, there we go. So we can see that lf my project is an MCP server, and I've got a Google Assistant and a weather agent. Great. So I can say, what is my next Google Calendar event? What's the weather gonna be during that time? I've never actually done this before, so I'm interested to see what's happening. And this is how agent. So I'll check your next for that time. So here it's creating for the Google Assistant tool an input value, and it's asking Langflow. It's literally talking to the Google Assistant tool in Langflow. And while it does that, let's go quickly look at this tool. So if we go here, how does this work? Well, we have Gmail and Google Calendar integrations via Composio. You just give them an API key, connect them to an agent as tools, and then you have chat input output. It's really that simple. You just plug a bunch of stuff together. And since this is running locally, there's no real data issues, but you can host Langflow. We have content on our YouTube channel about how to host Langflow. If you go to Langflow, youtube.com/@Langflow, you can host this on the internet, and then you can have this one MCP server remotely and use it wherever you are, your phone, your laptop. Possibilities are endless. All right, let's go check Claude Desktop. So it's asking for permission to use the weather agent. I will always allow. So it did check my Google Calendar and it got back a bunch of stuff. And here it's checking the weather for October 6th. Your next calendar event is read top 5 emails scheduled for October 6th, 12 p.m. Perfect. The description notes time to review the top 5 emails. Regarding the weather during that time, I I'm unable to provide that for the dates in the past. Okay, well, what calendar events do I have on November 8th? Oh, sorry, not November 8th. May, well, what a month, May 8th. And what will the weather be? And I think we'll sort of land the plane and wrap up here because we did cover a lot of ground and I want to leave room for thinking and reasoning. But I hope in our time together, honestly, we've just made agents way more accessible to you in terms of like semantics and definition, but also how you can build your own. Let's take a look at the output. It's generating. And the cool thing again is you can ask subjective questions. Will the weather be good? And the language model will have to decide that. Isn't that awesome? You don't have to think about, and then if it doesn't know, does the person like sunny or cloudy? What is good to them? It'll just ask you. That's the beauty of generative AI. So it got back my calendar events for May 8th, 2025. It check the weather. Here you go. So here are calendar events for May 8th. These are actually all of my calendar events for May 8th. We have an all hands and a DevRel weekly regarding the weather. They're only reliable for about 10 days in advance. It's too far in the future. What do you mean tomorrow's May 8th? Sometimes agents don't know what today is. In any case, that's how you can do it with Claude. Let's look at maybe one more MCP client and then wrap up. This is Cursor. Cursor is an MCP client. So I'm going to go to settings, Cursor, and Cursor settings. And I'm going to go to MCP and just paste that Langflow configuration here as well. And now, boom, I've got Google Assistant and Weather Agent. So let's pretend I'm like vibe coding. I'm writing like a big Docker compose, whatever. And I open the agent and I'm like, hey, anything important in my calendar for tomorrow, May 8th, just in case? What's the weather? Should I lock in or do something else, right? We often want to know this. And so I'm going to just ask this. And it's going to, while I'm coding, it's going to use MCP. So it's going to, yes, ask for permission to use the tool. And I'm just, let this pretend I'm coding. Let's do some like, sure, let's add some stuff. Wow, I'm such a lead code. Let's make a new TypeScript file, it looks like there are no events marked as important in your calendar. Now for the weather, yes, brilliant. And I'm just continuing to code here, const, cool, it's using the weather agent, AI crush equals, cool, look at this, amazing. I'm totally like vibe coding right here, vibe coding. And so I can like lock in and do my job and look at this, it just uses my tools. Incredible. Langflow has native support for MCP. I'll leave it here. Thank you for watching. I hope this has helped you significantly understand what agents are, how to think about them, and how to build your own. If you want to, Langflow, as I mentioned, is open source. You can find us on X at Langflow AI. You can also on YouTube/Langflow. And it's open source. So github.com/LangflowAI/Langflow is where it's at. Feel free to drop a star. We have a Discord too if you want to ask questions. I'm happy to answer them. I really think this is a great way to build agents, especially also MCP servers. And we'd love to see you as part of the community. Hey, thanks so much for your time.
Next, we have Power Up LLMs to be Factual Ninjas using GraphRag with Siddhant from Neo4j. Siddhant, the stage is yours.
Hello, everyone. Welcome to AI Crush. I'm super excited to talk to you about a very interesting topic, how to power up your LLMs to be factual ninjas using GraphRag. I was super excited to talk to you all in person, but unfortunately we couldn't do it, and I'm doing this virtually. Well, we all know that we are living in probably in the fifth revolution world, in Gen AI world, where LLMs have taken over, and we're using ChatGPT, Gemini, in almost every day, but there are still chances of hallucination. And the very fundamental question is always there: how do I make sure that I give LLMs, or rather not give LLMs, the access to my enterprise data, but still make sense of what my enterprise data is all about, and combine it with the power of LLMs? So that's where I'm going to talk about how do you use GraphRag as a concept and still make sense out of your enterprise data. Before beginning, a quick introduction about myself. I'm Sid, and I take care of developer relations activities across Asia Pacific at Neo4j. I started my career with IBM as a Java technology engineer, but soon turned my passion towards DevRel, community building, into profession, and that's what I've been doing for over a decade now. That's become more of my bread and butter now. Worked with Google and a couple of startups in the past. I recently also became a Google's developer expert in Gen AI. That's my LinkedIn profile, QR code, if you wish to get connected with me later on. Well, before beginning, I also want to make you understand about graphs. So, well, the topic is about GraphRag, but let's understand what graph is. So when you talk about graphs, probably this is something that comes to you. We don't mean this sort of graphs. These are charts. These are bar diagrams or pie charts. Well, yes, that's also kind of a graph, but in the graph database industry, or the database industry, when you talk about graphs, we are referring to these sort of graphs, which is powered by graph theory. So I'm sure you would have heard of graph theory or have read somewhere. So let's take it down a little step into the depth of it and understand what are the graph components. So graph essentially consists of nodes. So these nodes represent things. For example, let's take a movie's data set. So we can say that Toy Story, a movie, is a node. It could be a product, it could be a car, it could be a location. It's something physical, essentially. So these nodes represent our things, and they are identified by one or more labels. So for example, I can give a label of movie over here. I can also give an additional label and say there's an additional label of animated to this movie. Now, nodes can also hold data in the form of properties as key value pairs, and we can say title is Toy Story, released is 1994 or 1995 or anything, plot or anything else. So that's where properties are relevant. The power of graph comes in the relationship between data. So imagine if I have another node, which is, let's say, an actor node representing the actor Tom Hanks. The relationship between the two, the actor Tom Hanks and the movie Toy Story, would make a lot of sense, which is where the relationships come into picture, because these relationships connect to nodes explicitly by something called as relationship type. I can say an actor acted in the movie Toy Story. Now, we know that Tom Hanks acted in the movie Toy Story, but there's also something additional similar to nodes, which is before that, there's a direction as well. So direction goes from actor to a movie node. Now, as I said, the additional information that we can hold in the form of properties within relationship types as well. So we can say the role that Tom Hanks played was that of a Woody character. So like nodes, relationships can also have properties. Relationships are real things in my graph. There's a key difference between relational databases, where relationships are abstract, and a graph database, where relationships are our first-class citizens. Okay, but why graphs? Why are graphs useful? And when are they useful? So let's talk about that in a while, going forward. So going back to our movies data set, imagine if we have, let's say, 3 separate tables, one for directors, one for movies, one for genres. A simple one-to-one relationship between its movies, directors, and genres might look something like this. But we know that movies can also have multiple characters. So let's change the schema a bit and add in an additional table. Let's bring in an unnecessary complexity, which we're doing it over here. And then we also know that movies can also have multiple genres. So we again have to go back and change the schema. So essentially you're seeing that you're being forced with a strict schema, or you use complex joins to avoid data duplications. Eventually the multiple joins are leading to poor performance. And this is definitely not suitable for your unstructured data. Versus if you look at it in a graph way, in a graph format, something like this, it's going to be super, super easier for you to make sense out of your information. And what amazing is this, that it's super efficient in handling your relationships. There's no data duplication. And it's, of course, easy to maintain data consistency. And there's a built-in query language. That's where Neo4j or graph databases are really, really powerful. So when do we typically use a graph? When do you see that there's a graph problem? So if you find yourself in situations where you're struggling with complex data structures or database structures, when your database schemas are large, unwieldy, or they're full of linked tables to represent many-to-many relationships, that's somewhere a graph problem, for sure, yes. Or if you have poorly performing database queries, when you need to understand the relationship between entities. For example, how people are connected. Are a database queries complex? Do they take an age to return any results? Definitely, there's a time for you to move from a relational database to a graph database. Or you have to store hierarchical data or complex networks. Are the connections between data as important as an individual data point? Definitely a graph problem. Or you have to analyze connections between the data rather than the data itself. Do you need to explore and calculate paths between 2 data points? These are graph problems and can be better supported with a graph than a table. So definitely, graph databases are the way to go, because these are designed from the ground up to efficiently handle the highly connected data sets from the underlying data storage to the query language. Let's take an example. Let's look at, which is probably arguably the most efficient piece of investigative journalism of the last decade, the Panama Papers, which also won, by the way, a Pulitzer for exposing corruption on a massive scale leveraging offshore assets. So what happened was ICIJ, International Consortium of Investigative Journalists, was handed a hard drive with millions of documents, 11.5 million documents to be precise. And that's on a 2.6 TB of a hard drive, which not just contained your bank statements, which makes sense to identify corruption in the money movement. But there were also scanned documents, there were emails, but none of it was in this exact form, but rather they were trying to make sense out of it. So eventually, let's say from a piece of document, they eventually found a person's name, and then they found from another piece of document that there's an account, a reference of an account, and then that account is with the bank. And at the same, that particular person lives at a particular address. That address, at the same address, there's another person, person B, who also lives at the same address. Now, this person B is an officer of a company, and this company has registered with the bank in Bahamas, and that's where the money is moving around. This ultimately led them to extract entities from the documents, bring the connections into graph, and they were able to detect all sorts of problematic activity, and particular undeclared hidden offshore assets. And as I said, it's a very small portion of a bigger graph as well, right? So if you're wondering how does a relational to a graph mapping looks like, this is something for your reference. You can take it. How your roles are mapped gets mapped to your nodes. Your joins maps to your relationships. Your table names maps to your labels, and then your columns maps to your properties. Okay. In a nutshell, Neo4j is a native graph database. We also have a lot of graph data science and analytics capabilities on top of it. There's a whole ecosystem out there who is building amazing stuff, open source stuff on Neo4j, but there are a lot of integrations and support for other ecosystem components that we have built natively as well. We run anywhere. It's on-prem, it's on cloud, and it's also on cloud managed services as a cloud managed services. Here's some of the popular use cases, one which we covered just now, but then these are a bunch of other popular graph use cases. But again, not just limited to them. We practically say graphs are everywhere, and I'm sure you would see that graphs are also everywhere when you really look into it closely. We are living in a graph world. Graphs are literally everywhere. Okay, with all this blabber about Neo4j and graphs, let's jump into our actual topic, which is RAGs, retrieval augmented generation, or when I say RAGs, it's RAG, retrieval augmented generation, and how do you achieve it with Neo4j? Okay, so we all know this for a fact that LLMs make things up. They hallucinate, and they still do. I'm sure you won't deny this fact. They still do. They're still gonna hallucinate, and giving your enterprise information is definitely not something that you want to do it. So we know that retrieval augmented generation, RAG, is becoming an industry standard. So when ChatGPT came into picture, they democratized the entire GenAI world. But the challenge was always, how do you put in additional data source and external data to extract much relevant information? And that's where RAG became an industry standard, where now you're not just only giving a prompt and getting a response, but when you're giving a prompt, the retriever goes and then checks an external data truth, retrieves additional information, combines it with your prompt, gives it to the LLM, and then you get a better and complete answer. So when RAG came into picture, Vector RAG was also introduced, where, let's say, supposedly you have unstructured data, imagine PDFs. You take those PDFs, you chunk them, divide them into multiple chunks. As in, if imagine your PDF is 300 pages, each page, each paragraph, or maybe less than a paragraph would be maybe a chunk, for instance. So you have multiple of those text chunks. Now, what you do with these text chunks is you convert these text chunks into something which LLM can easily understand or can go back and make sense out of what's there. So you convert them into vectors. Now, what are vectors? Vectors are your an array of numbers, simply put. So you have, let's say, 1, 2, 3. It's a vector in a 3-dimensional space. Now, in a practical world, the vectors can be of thousands of dimensions, hundreds and thousands of dimensions. So you can have a vector which is 76 or maybe a higher dimension, right? So you'll have numbers. Now, what are these numbers? These numbers represent the semantic or the similarity meaning or semantic meaning of what the text looks like. So the text is converted into a vector. Now the vector can be easily understood by LLM. Now you need to have a database to store these vectors. You need to have a vector database to store them and make, when a user asks a question, the retriever can retrieve information which is of a semantic meaning to an existing information, and then retrieve that information, combine it with your query, give it to the LLM generates a new answer and give it to you. Now the responses are much more accurate and much more efficient as compared to what it was in a pre-RAG world. But having said that, there's still reasons why a naive vector RAG alone might fail. Because vector RAG just focuses on your semantic similarity, and the retriever fails to find the relevant context. So imagine if I have to find what are the payment terms for license agreement with Ackman Corporation, it might find hundreds of documents that have reference to Ackman Corporation. But what I'm referring is the payment terms for license agreement with Ackman Corporation. So the exact relevant context-driven result might not be fetched in a case of a vector RAG. So that there comes in GraphRag to your rescue. GraphRag really, really helps in overcoming all of those shortcomings which are there in a vector RAG. but we are no way getting rid of vector RAG. So vector RAG is still going to be there, but it is an additional component of graph RAG that comes into picture. So what happens is that when you have an unstructured document, you of course convert them into vectors, but you also extract entities out of that vector. You create a separate graph out of that unstructured, out of the extracted entities. And then you pass that entire context to the LLM. The LLM generates a final answer for you. So let me introduce you to knowledge graph. So as I said, that your unstructured data is also in the form of vectors. Now these vectors are also connected to each other. These chunks, the vector chunks, are also connected to each other, forming a document or a lexical graph, as you see on the right. And then just below that image on the right, below that image, you'll see there's a domain or an entity graph, which is your extracted entities from these chunks. So your domain graph is a graph for your chunks, and then your entity or a domain graph is a graph for your extracted entities. Now, these two graphs are not lying in isolation. These are rather connected together. The document graph is connected to your domain graph. So you extract entities from your chunks. You also reference them back to your domain graph, document graph. As you see on the left as well, there's a nice reference of a knowledge graph, which you also see in Google search these days, that Google combines and then takes in information from multiple sources and then gives you a nice, concise view of what you were looking for. Right. So, let's go in the depth of it and then try to understand knowledge graph from an enterprise standpoint. What is truly enlightening that in enterprise, you probably just need 7 graphs. So let me explain that every business has a customer hub. Normally, this is where sales, marketing, customer service, field service falls into. They're servicing someone. They have data, acquire data to serve the customer better. So if you store the customer data with relationship first model, then you do not have to store first in a relational based SQL with rows and columns, and you only do ETL into an analytic solution and perform many-to-many joins to connect all the relationships. You can do everything within a knowledge graph format. And similarly, you'll have data for your suppliers, your processes, your transactions, identity and security, human resources, the network, or a graph. And you'll find pattern emerge automatically from the data. Now for RAG, what kind of data sources do we typically use? So yes, we have the unstructured data, your text, images, etc. And those get converted into vectors, and you also extract entities out of it. You can, of course, use structured data, your relational data, your flat files. You can also use semi-structured data, your NoSQL documents, etc. And then all in all, everything is helping you form a knowledge graph, which acts as a superset of the data structure for RAG. These knowledge graphs are super powerful, and I would definitely encourage you to go back and read more about this Graph RAG Manifesto, where we talk about how do you add knowledge to GenAI, to your data. An amazing blog written by our CTO, Philip Rathlee, on how Graph RAG can be really, really helpful when you want to add knowledge to your enterprise data. Okay, that's not all about Graph RAG, by the way. The Neo4j Graph RAG ecosystem is very robust, where we can help you build knowledge graphs. You can converse on those knowledge graphs, and then, of course, there are a lot of LLM framework integrations with graphs as well. Now, we understood that building a knowledge graph in the first place is going to be super tiring process. It's a very extensive process to extract entities, what entities to be extracted, what not. So how do we make your life easier is where we build this nice LLM graph builder tool. Now, what exactly this tool is, this knowledge graph builder tool is an all-in application which turns your unstructured text into a knowledge graph. It provides a magical text to graph experience. So 3 simple steps. Connect to Neo4j instance. You upload your files. It could be PDFs, YouTube, cloud storage, Wikipedia, anything. and then just click on Generate Graph. It uses, of course, LLMs behind the scenes, models like your OpenAI, Gemini, Diffbot, etc. The bunch of LLMs that we provide you for free in production, in the production environment of this tool, that can help you transform your PDFs, documents, images, web pages, or YouTube video transcripts into a nice looking graph. The extraction turns them into both lexical graph or a domain graph, and also your entities are extracted from these chunks as well. And the entity graph will have nodes and relationships as well. So both of them are stored in your Neo4j instance that you initially connect with. And then you can, of course, configure the extraction schema. You can apply some cleanup operations after the extraction. And the interesting part is you can test the power of GraphRag within the tool. Just chat within the tool. There are a bunch of retrievers that we have. So you can play around with the retrievers. You can test it in a full vector only mode, on a vector plus full text mode, or a vector plus full text plus entity mode. So you have options to see how the response varies when we do just only one type of operation on the same data set. So if you want to explore this tool further, I would suggest to head to this link. You can read more on the documentation provided. As I said, this tool is available for free. You do not have to pay anything to access this tool. Do check out the documentation and you can read more about the tool. And this tool is also available as an open source project. If you wish to contribute, please head to this GitHub repo, raise issues, PRs, or even try and test it with your local LLMs. Yes, you can also run it on your local, as a local instance with your local LLMs, probably with, let's say, Llama. You want to run it with Llama, with Ollama, or with DeepSeek, or any of the LLMs that we do not support. You can also run them directly within the tool as a local instance. Okay, so that's the tool that we helped you build a knowledge graph, but we also created a GraphRag Python package. So this is for people who want to have further control on what kind of knowledge graph it's being built. So you can use this GraphRag Python package. The Graph Builder tool was like a no-code environment. The Python package would be like someone with a full development experience. They can just build the knowledge graphs. They can implement the knowledge graph retrievers. So we have built in all of knowledge graph retrievers. You can create your own GraphRag pipelines, combine the entire RAG process with retrieval, prompt, and LLMs with just a few lines of code. It's very simple to use this package. And as simple as that, you can just do pip install neo4j-graphrag. And that's it. Your job is done. Okay. So all in all, Neo4j doesn't act as a standalone database, just helping you with the knowledge graph. Of course, we are graph database category creators and category leaders as well, but we build an entire GenAI ecosystem for you, build a native integrations to help you build an entire GenAI stack. From applications, the top level, the front end view of the applications, to orchestration via frameworks like LangChain, Llama Index, Haystack, Spring AI, to integrations with generative AI and embedding models, which ultimately helps you in grounding your knowledge by building knowledge graphs within Neo4j. And I'll leave you to this reference architecture as well. We'll be wrapping up in just a couple of slides after this with resources. So this GenAI reference architecture will help you understand how to implement an end user application or a use case. Again, not just limited to them, but just giving some reference for you. So you'd have the data sources, which could be structured, unstructured, semi-structured. You use either the GraphRag Python package or the LLM Graph Builder tool. Extract information, entities, build a knowledge graph, do analytics if you want to. There are a bunch of other visualization tools as well, graph data science as well within Neo4j. And then you can build a conversational application or any other front-end application with the native support with the programming languages that we have, frameworks that we have, and build your end user application. Okay, that's it from my side on GraphRag. I didn't want to bore you all. So leaving you with a couple of more resources to explore further on what's there in the world of Neo4j and GenAI. These are some use cases, some resources for you to take back. I'll definitely encourage you to go and check this documentation page on neo4j.com/labs/GenAI-ecosystem. A lot of amazing integrations and tools are directly available over there. You can get started with Neo4j or free as well. There's a sandbox also that you can play around and test your skills on Neo4j. Check out GraphRag examples on this GitHub repo. You want to get a hands-on experience, I'll definitely encourage you to go back and check out graphacademy.neo4j.com. It's an amazing platform where we have built a lot of hands-on courses on not just Neo4j, but there are courses on Neo4j and GenAI. There are free certifications. There's curated learning path that you can create for your own. And last but not the least is Nodes Conference. It's back for the 7th year and it's taking place on November 6th. For those of you who are new to Neo4j, Nodes is our online developer conference that airs for 24 hours in all time zones. Last year we had 145 technical sessions compared to 110 the previous year. So there are Neo4j sessions, there are community members present, there are partner sessions and more. This really is the event for graph developer community. So talks for this year are bucketed into applications, AI engineering, data intelligence, general graph topics, and architecture as well. The event is free, and we welcome you to attend. To also submit your proposal if you have. We invite customers, partners, everyone to join this conference. So register at neo4j.com/nodes-2025, and I look forward to see you at Nodes this year. Thank you so much for joining in. Have a great rest of the conference. AI Crush is amazing. Thank you, Neil, and the rest of the organizing team for pulling up a great show. And hopefully, I'll see you in person next year at AI Crush. With this, I bid adieu. Thank you so much. Bye. Take care.
Our next session is by Rob, the YouTube wizard himself, mastering vibe coding from chaos to control. Rob, the stage is yours.
Hey guys, I just want to say a big thanks to Niall for inviting me to the inaugural CrushConf. And what I wanted to talk about today was basically vibe coding. We've all probably heard it, being that this is an AI conference. It has good connotations, bad connotations, and in reality, what it does allow us to do is move really fast, but then we end up in trouble. So what I want to talk about today is taking that chaos and putting some control around it, and how I actually build out applications, not to be tongue in cheek, but actually 10x faster than I previously could. And I cover all this on my channel. So let's just jump in. So quick introduction to myself. My name is Robert O'Shaughnessy. I have a YouTube under Rob Shocks. My own background, I have about 20 years of experience developing software applications and also in product management. I had my own startup where it was backed by Enterprise Ireland and NDRC. I ended up selling that to a US company, and the theme of that company basically, or the theme of my startup, was using AI to translate websites using a translation proxy. We used to pull content off websites, regenerate it using machine translation or AI, and then serve it out into multiple different languages. And then I went on to work for multiple different clients through that acquisition, like Porsche, CrossFit, Cisco, working in product management and AI transformation, pulling content out of systems, translating it, transforming it, and pushing it back out. So around about 2022, ChatGPT came out, and I got very excited, quit my job, and this is what I was going to do, focused on basically learning everything I could about generative AI and how I could apply it to various different projects for my clients. And then I started a YouTube channel around that topic, all the projects I was building out, how fast I was moving. And you can check out multiple different videos there if you're into this kind of thing. I cover multiple different types of builds and a style of vibe coding, if you will. So how have we arrived at this point in time? So this is no news to most people at this conference, but we've had this big jump in ability, which is natural language as an ability to code and develop. If you watch any of my videos, you'll see that I use natural language in the form of actually using my voice. I use either WhisperType or Aqua or any other tool like the dictation that's built into Windows or Mac to just prompt apps into existence. I built out this application in my course without writing any code. Maybe I added or edited some environment variables or something like that, but the majority in a full stack application was written purely using AI development and my voice. So let's just have a quick demo. So there's lots of different tools that you could possibly look at. I'm going to talk about the pros and cons of each one, but one that's fairly popular is V0. So essentially what I did, just as a quick demo, we don't have time to go through the whole thing here, is I just copied the content off the CrushConf website, and then I went to V0 and I basically used this prompt, create a landing page based on the content attached. I pasted in a snippet, and then I took a screenshot of another website that I liked that I saw on Pinterest or Dribbble, and then it went and built out this landing page for me. So literally this was a one-shot prompt, and this is what I got. 20 plus speakers, attendees, the date, the different tracks. It used an API to pull in sample images. It gave us different tracks in a table layout, some of the pros and cons, and even a sign up form at the very end. Now this is very basic. This is just a landing page, but literally this was one prompt. Previously, this is probably maybe a day's work or a day or two's work for a competent developer, and you can pull this off now in just a couple of seconds. So I'm sure you've seen these kind of things before. The kind of stuff that I do on my YouTube is a lot more complex than this. These are kind of the novelty demo applications, but I just wanted to give you a sense of what we're talking about. And you can see all the code in the background here as it's broken down. Cool. So basically, your path with AI, if this is how you set out, essentially you're going to start off pretty much like this. you're going to use a tool like Lovable or Bolt, and you're going to be blown away. You're going to think that's the end of software development. My job as a developer is gone. It's the end of SaaS. And you see all these headlines like an 8-year-old creates an entire application. And then you move into a tool like Cursor or Windsurf that's highly powered, and you think you're just going to go to the moon. You're going to be building, the next Google, the next whatever, insert large startup here. But then you start to run into issues with your so-called vibe coding. You end up swearing at your application. You get frustrated. It builds out a load of spaghetti code. It deletes part of your code base, and you find that it really starts to lose context very quickly. So this is a common path that I've seen with people that show up on the channel or start to chat with me if they've first tried vibe coding. So what I want to get people to is a point where they have this kind of competence where they work alongside the AI in a kind of in a competent way, checking their code almost in a pair programming sense. So this is kind of a happy medium between this like shoot for the moon vibe code and then the handcrafted code that we're used to. So the first thing I'd like to talk about is like the best models to build with. So the ones I would use most often would be either Claude, OpenAI, or Gemini. Majoritively, I'll use Claude 3.7 or 3.5. We'll talk about the pros and cons of those models in a second. OpenAI, the O3 and the O4 mini models are fantastic for doing some upfront thinking or planning about your application. And then also Gemini 2.5 is pretty much the same and has a really large context window. So you can fit in a lot of context and larger code bases that you are working with. So now let's talk about AI coders or IDEs, development environments. So essentially, one thing we want to talk about before we jump into that is who is this new skill of vibe coding for? Well, it's the same as always. What you want to be is, pretty technical. You don't need to be necessarily a senior developer, but you do need to be competent and technically minded. You don't need to have written loads of software, but you do need to have an appetite for this kind of thing. So you might have done some coding basics, built a website in the past. This fits really well. So you can just fit in here, and then also works really well for senior developers. And I'll show you, how a senior developer would incorporate it more as time goes on. Cool. So let's talk about the app building tools that are most popular. Now, there is a ton on the market. You have everything from Lovable up to Cursor. So if you're starting out, people often use these kind of applications, the Lovable, Bolt.new, they might use Replit. And the beauty of these is that they're really hands-off. They allow you just to use the prompts. They'll allow you to deploy. They even help, integrating a database and different things like that. You can get a lot done with these in terms of basic applications. However, when it gets more complex, you're going to need to switch to something like Windsurf or Cursor, which is more like a traditional IDE that you'd be used to, like VS Code. And then it just requires a bit more of the advanced knowledge. So this is what an AI coding agent looks like. This is actually just a fork of VS Code. This is Cursor AI, probably one of the most popular ones. So you see you've got on the left hand side, you've got your typical file structure. You've got the page in the middle, which shows all the actual files. A terminal down here helps you run the server or interact with the file system. And then this is where all the magic happens over here, where you can chat with your AI. So next thing you need to think about is what kind of stack you're going to use if you want to be successful when you're working with AI. So what I'll typically use is this kind of a stack for building out front-end applications, but you need to just think about it in terms of popularity of the language and the framework. If you think about how these models work, they're crawled on basically the most common content on the internet. So if you're trying to use something that's very obscure or not a popular language, you're going to fall into issues. So languages like Python and JavaScript, TypeScript are really great to work with. Also, you need to think about the cutoff date of the model. So if this is a very new framework, a lot of models have cutoffs at certain points in the year, maybe November 2024. So if this is a new framework that you're using, you need to be aware that the model won't be aware of the recent changes, and you're going to need to add some kind of context so it knows what you're dealing with. So the next big tip I would give you is that you need to plan ahead, and this flies in the face of what traditional idea of vibe coding is, where you just dump your thoughts and then move very quickly. I would highly recommend that you take the time to do some forward planning. And on my channel, I talk about this process called the 3 experts. You have a product manager, UX designer, and a software architect. And the idea is that you basically feed in different prompts. Let me see, where's this page now? Give me a second. Yeah, so basically you can feed in these different prompts in order to get yourself up and going. And this is actually free. I'll leave the link so that you guys can get to it. It's at notes.switchdimension.com. But basically what you have is a set of prompts that talk you through your project, what you're setting up and why, and it outputs a software requirements document along with a design document. So what you get is these different documents, and then you can go and you can add those into Cursor in the left hand side here to give the model context for what it is you're building next. So if you just take a quick look here, you can see an elevator pitch, who's this app for, functional requirements, and we use that to inform the model about what to build out next. I'll also have a project log which I'll use to keep track of what I'm doing and what we're going to be doing next. And then also a software requirements specification gives an idea about how I like to build apps, how we do the processing, the technical stack, etc. Cool. So adding context. Let me just check I've got the right screen up here. Yeah, perfect. Cool. So adding context. So this is super important for the reason that we talked about earlier. The model will basically crawl everything on the internet, and it has a certain cutoff date. But let's say you've got a new framework that you're working with, or an API that might be pretty much obscure. What you want to do within Cursor or Windsurf is use the context ability. So you can add in docs. Cursor will have actually crawled a certain amount of documentation. It might be in there previously. Or I would navigate to, let's say, the Stripe documentation page or the Prisma documentation page, and actually just paste it directly in here, and then tell the model to reference this so it knows the right way to install. And that saves an awful lot of trouble with outdated methods or different calls or tools or different things like that. So highly recommend you use context as much as you can. There's also an MCP I'll talk about in a few minutes which can help you with that. Next thing I'd recommend is working step by step. So again, the idea of vibe coding is you just blast through it and you use these things called one-shot prompts that will build everything out in one go. But the problem is when you have an over-enthusiastic model, it generally might go in the wrong direction. So you need to move slowly and just check exactly what it's doing. So some of the prompts that I would recommend is working with your agent to plan first and don't implement. This is actually what I'll say in the prompt. I'm like, okay, I want to plan out integrating Stripe into my application. Let's plan this out. Show me what it is you think we should do, but don't actually go ahead and implement it. So then I can get a sense of if the model is on the right path. I can correct it. I can add in more context before I start to actually get it to implement the code. I also might say, give me 3 options and your recommendations about how to proceed. And then it generally gives 3 different paths that you could take. This is useful if you're trying to figure out how to structure your application. When it comes to bugs, I'll say explain and fix. If you're in a hurry, you just write fix, but oftentimes you want to actually get an explanation for what's going wrong, so you as a developer are learning as you go, and that's very important. Next thing, you would say something like, let's move step by step, start with step 1. So once I'm finished doing the planning, it'll have given me a list of steps, maybe 1 to 6. I'll ask it to start with the first step, and then I want to verify that step was done correctly before it moves ahead. Using models like Claude 3.7, it tends to jump ahead really quickly, and it can actually end up getting you in trouble. Okay, so and the last one then is, evaluate for security vulnerabilities. Now, this isn't a catch-all, but it's just important as you're moving through that you're thinking about what vulnerabilities might have been introduced when the code was developed. So next tip is to learn the model's pros and cons. So again, these are the kind of most common models. Anthropic, really great, 3.7, 3.5 at the actual implementation of the code. And then I would use something like O3 or O4 Mini to do the thinking stage of trying to decide what to build next. If I'm having troubles or getting errors with one model, I'll often go and chat to the other model just to see if it has a different perspective. DeepSeek is generally cheaper if that's what you want to do in terms of plugging it into Root Code or Klein. Gemini has a large context window, and I rarely use these guys, but they have their own set of pros and cons. So you need to think about your new pair programmer in terms of what it's good and what it's bad at. So it is an expert. It knows way more code than you will ever know. It's 100 times faster than you ever will be, but you always need to be managing the context. You only get to send a certain amount of your code base, a certain amount of your past conversation and documentation in one send to the model, and it only can send a certain amount back. So Cursor and Windsurf do great things in terms of managing memory and context, but you always need to be aware that it might forget the start of a conversation or omit important details. And remember that it's eager to a fault. It's always going to agree with you. It's always going to kind of rush ahead. You need to be the one that kind of thinks of it as an intern and gets it to slow down a little bit and give it some confidence in its own decisions. You absolutely need to review the code. If you're doing a play project and you just want to blast through something, it's fine just to vibe code, if you will, but you need to actually go and review each parts of the code as it goes through. So in Cursor, what that looks like is as you're developing, you'll get a window here which will show you, how what the past code was, and you'll see a difference here in terms of green and red in terms of what you want to accept. So it's important that you're kind of reviewing the code. You can also do this thing where you highlight any particular piece of code that you might not understand. You can hit Command K and then you can ask a question like explain this code. So I'm often doing that when a new code has been injected or set up. It might be doing something in particular I don't understand, I might not have learned before. I'll ask it to explain it, and then I'll go to ChatGPT or something like that just to give me a grounding in what's happening. You want to be learning as you're progressing. The AI might be writing the code, but you still need to be learning about why it's doing these things. Otherwise, your skills are going to atrophy. And then importantly, is testing. Now, I'm not the biggest fan of testing myself in normal software development, but it really has a place within AI development. So there's different types of testing. There's unit testing at a more granular level, integration testing between systems, and then end-to-end testing. You don't want to go overboard on it. It's useful to write some end-to-end tests and then actually getting the model to do some unit testing to get yourself set up. And why this matters is as you're developing out more code and more features, and as AI starts to move faster and you want to deploy, you want to make sure that you haven't broken everything that you've done before by running these tests. If you're using Next.js, Jest or React, Jest is a good option, and then there's also Playwright and Cypress and a few others like that. Just get your friendly AI to teach you about how to get it set up and how to use it. But be mindful of the fact that AI is really good at passing tests, even if that pass shouldn't necessarily be test. It's just basically trying to fake its way through. So you need to be mindful of that and be aware. Saving your game is obviously huge, and we're using Git, of course, to do this. Huge fan of version control with AI. It's very important if you want to move at any pace. You're going to need to commit way more than you would if you were doing a regular software project. And so what you want to be doing is every time you've accepted some changes, you can press this little button here in Cursor, which basically will give a full overview of what happened or what you worked on. You can edit that if you will, and then commit it, and then have a record or a save game, if you will, to be able to move back in time. So I will, at a more advanced level, use branching. So when I'm just moving quickly, I might just use something like a git hard reset to move back in time. Not recommended for any kind of version control where you're working with other people or anything in production, but it's handy when you're doing hobby projects. But in reality, you're better off using branching. So I'll create a new branch for some new software feature or some new thing I'm working on with AI. I'll test it out in that branch, and if I'm happy, then merge it back in. And if things go awry, you can always just go back in time or delete the branch or whatever you need to do. So one of the final tips then in terms of power users is, power-ups for your IDE like Windsurf or Cursor. So MCPs have gained a lot of popularity in the last month or two, and essentially what they do is they are plugins that give your IDE superpowers. So one, for example, is Context 7. So what this has done is it's gone and crawled all the popular documentation across the web and made it available in a format that's really friendly for a large language model. So before we talked about context and cutoff dates, with Context 7, what it does is you can introduce the most recent documentation when you're installing ShadCN or any other component library or setting something up, and technically you'll have less issues in that case. Other ones I use are Brave Search, so that my IDE can search the web for documentation or fixes. I'll have an IDE for my database. It's a Postgres database, NeonDB, Supabase, they all have them. You can chat with your database or have your agent understand what's going on in your database as it develops things out. And then also browser tools, because that allows me to have my agent see what's going on in the browser by copying in the console logs and taking screenshots on its own behalf. So I wouldn't recommend starting with these, but once you get into developing or moving a little bit faster, these are handy MCPs to set up. Cool. So hopefully you got some usage out of that. That was really just a whirlwind tour. So much more I'd love to teach you about, but not in the scope of 20 minutes. You can check out switchdimension.com. There's a lot more content on that, and some of the free resources that I talked about are there as well. And of course, you can check out the channel as well. I have a ton of free videos you can make your way through if you want to learn more about, developing as fast as you can with AI. So in closing, I think this is the future. I know myself, having used this in practice for the last 2 years, I am moving a hell of a lot faster than I ever moved before. You do need to be aware of hallucinations, of problems, of your skill set atrophying, but it's here and it's now, and we need to learn it. And like anything in software development, it's a tool. So start to get your head around it. Okay, thanks so much.
Next up, we have Secure ML Packaging using open source project GitOps, and it's by Shivey Lama. I'm really excited to have him here, and Shivey, the stage is yours.
I'm going to be talking about exploring container native simplicity for AI/ML workloads. I'm Shivey Lamba, and you can follow me on X or Twitter at @howdevelop. And I'm also a community member of the open source project GitOps, which is currently being donated to the Cloud Native Computing Foundation and is undergoing application for being a sandbox project within the CNCF. So without further ado, let's get started. Now, we truly live in an era where we are seeing a lot of adoption of AI, and different companies are adopting generative AI in their workloads or shipping products that have Gen AI. Now, one of the key challenges that have always existed ever since the era of the typical machine learning models, and of course today with the generative AI models, is that transforming these AI models from these experimental Jupyter notebooks being written by AI researchers, data scientists, into robust production-ready deployable machine learning models can be extremely challenging. And there are a number of different reasons, because these experimental notebooks do not offer the capability of direct deployment with the help of a CI/CD solution or perhaps on top of Kubernetes. In fact, like a lot of times there are a lot of transformational steps that are required to move away from these experimental notebooks. And there's a really unique statistic over here that almost 80% of the machine learning models that are being written by the researchers or by the scientists never make it to production because of the model deployment issues or the procedures that we have just spoken about. So what is the biggest challenge today that we find with machine learning packaging? And the reason we are talking about packaging is that we want to move these models from these Jupyter notebooks into production so that they can be used. But the biggest one is that there is actually no standard for packaging and versioning the various artifacts which are needed to reproduce an AI/ML project. So of course, as we know that an AI/ML project is not just your source code with the version dependencies that you will have in a typical software. There are different pieces, or there are different puzzles or parts of the puzzle of a machine learning project. So it starts off with your models that are typically stored in your Jupyter notebooks or might be part of some MLOps tool. Then your data sets might be stored in a data lake or in a database. Your code for your project might be stored in a Git repository. And then all of the metadata that's involved with your model, such as the hyperparameter tuning or the features or the weights, might be scattered across different storage systems. So what you are seeing is that there are all of these moving fragments of a machine learning project, and they're all being stored in different locations. So being able to then get all of them under one location and then using them for productionizing them can be a big challenge. So there is this lack of standardization for packaging these artifacts, which is causing a lot of different issues. Now, why can't we actually use the same pipeline for MLOps, that we might actually use for conventional DevOps-based applications? So there are a lot of different reasons for that, right? So as we covered that, because of the fact that the nature of a machine learning project is a bit different as compared to a software project, right? So that's the reason that we cannot just directly just use all of the tools that we typically use for a DevOps project and apply that for machine learning. And that's also because for machine learning, you might actually need more expertise, and the complexity of running these machine learning projects is also significantly different, because you generally need things such as GPUs or even a cluster of GPUs if you're running very large machine learning models. So the above challenges have essentially led organizations to adopt a completely separate MLOps pipeline. However, implementing that comes with its own set of challenges, which is the data management and standardization, the running cost of having to deal with expensive hardware, security and compliance that has to be occurring with machine learning itself, right? And then of course, managing the complex model lifecycle, the different steps involving with pre-training the model, then training it, and then inference, all of those lead to their own set of challenges. And a lot of times the standard SRE teams or DevOps teams might not be equipped in order how to handle all of these challenges, because machine learning might be new for them. So if we explore this even further, we will have distinct workflows that will be for data scientists because they are working with Jupyter notebooks, or model training DevOps team because they are dealing with the deployment and setting up the infrastructure that is required for deployment. And all of this basically leads to increased cost because you're more often than not having to duplicate the efforts because you're having a separate DevOps pipeline and then you have a separate MLOps pipeline. And then you have to do the manual handoff between the different teams. So this increases the technical debt and can lead to inconsistent deployment processes, right? So if we kind of also look at how over the duration of time we have seen, the different kind of specific centric approach. So we of course started off with machine centric, where we were just running simple servers. Then we went into VMs because we found that there are a lot of inherent benefits of being able to run VMs, because then you can actually virtualize your software and not have to worry about whether it's supported on a local server or not. And then we went into container-centric approach, where we saw that we are able to ship your applications in a much more smaller footprint while not having to worry about the system dependencies, because you can run these particular small containers in the host VM, right? And not have to ship an entire operating system that we had to do with the virtual machine. So now, of course, we are looking at what we are calling as a model-centric approach, where we are able to actually containerize not only the model, but all of the different dependencies of a model. So how would that look like? If we were to build a model-centric approach, how would that look like? So that's what we're going to be covering in today's session. And that is where KitOps actually helps us to solve this particular problem. So KitOps is a completely open source standard-based packaging and versioning system that has been designed specifically for AI and ML projects. So what KitOps allows you to do is that it takes advantage of your existing software standards and tools that can be used by the DevOps and the SRE teams to basically build containerized applications. So the idea is that it will use the similar OCI compliance format, which allows you to package your standard software applications as container images, and then you can deploy these container images on any model registry, or for that matter, a private or a public registry. We can use those same set of tools and use an OCI compliant format such that it can be, you can take all of the different components of your machine learning model systems, and you can basically package the different components, which are models, data sets, and metadata, into a format that is called as model kit. And this model kit is completely OCI compliant. So KitOps allows AI teams to not have to deal with all of these different locations where different parts of your model are being stored. You can store all of them together into this model kit. Now let's dive deeper into what this model kit basically means. So at the heart of KitOps, what we have mentioned is model kit, which is, as I mentioned, an OCI compliant packaging format that will seamlessly take all of the different artifacts that you have in your machine learning lifecycle, and this basically includes the data set and the code configuration and model itself, and package it together into just one single unit, which is called as the model kit, and then can be deployed to any OCI compliant registry. So whether you have things like a Docker Hub, or you might have a private cloud-based registry like a Azure registry, or an AWS or a Google registry, you can deploy this particular model kit on those same set of registry, right? So it uses the OCI compliant standard, and of course you can basically version all the different parts of your code. So at the core, you will basically define what we call as a kit file, which is similar to like something like a Docker file. And then your model, the code, dataset, documentation, all of them will be packaged together. Now, the kit file, as I mentioned, is what is complementing, like how we have a Docker file that complements the Docker image. Similar to the model kit, we have the kit file, which is a YAML based configuration file, which simplifies the description that, okay, like what are the different components that you will have. And of course, this kit file has been designed specifically with ease of use and security in mind, so that you can basically efficiently package your software. And this is how like a typical kit file would look like. So it will be a very similar to a YAML file that has been designed to encapsulate all of the necessary information that you need to actually package together. and this manifest will be broken down into the different sections, which is the manifest version. If you're having the package details, then the code, the dataset, and where exactly they are stored, because all of them are then packaged together into the model kit. And then finally we talk about the kit CLI, which is like similar to like a Docker CLI, where the idea is that you get a set of command line tools that enable the users not only to manage, but to also go ahead and create and run these model kits and then also publish them. So you can have your kit file and then create the kit, the model kit from it, and then go ahead and actually deploy to any container registry that you want. Now the great thing over here is that since these particular model kits are compliant with OCI compliant registry, that means that you can use the set of DevOps tools, whether it's CI/CD tools, deployment tools that you would typically use with a container image, because these are similar to like a container image. That means you don't have to reinvent the wheel and introduce new tools for machine learning based systems. And that's the entire idea about reusing your software, right? So that's the kit CLI. Now let's look at how a typical KitOps pipeline would look like. So the kit unpack would allow you to pull model kits that have been stored in a private or a public registry. They're like a Docker pull, or Docker unpack. So what it allows you to do is that when you do kit unpack, it will pull the model kit and then it will produce all of the individual components that you had locally stored, that you had stored in the model kit as separate files. And we'll see that in action. And then kit pull will allow you to then retrieve a model kit that has been stored in a remote registry into your local environment. And if you want to create one from scratch, so you can create a new kit file for your AI project, and then you will use the kit pack command to basically create the model kit from that kit file. And then you can use the kit push, which is like similar to like a Docker push, which will allow you to push your newly created model kit from your local repository to your private cloud-based registry. And you get a lot of things out of the box, because you can also sign your images, so that increases the security. So if you want, because of compliance reasons, you want your AI models to be more secure, then you can leverage the kit push with signing of the images as well, right? So it comes with inbuilt security. So with signing, you can know that the model kits are actually verifiable. So let's look at a demo. And we are going to be seeing a demo of the kit file. So here I'm going to be running a kit CLI where I have opened my terminal. I have already installed kit CLI. So let's take a look at how that would basically function. So I'll proceed a bit further and show you. So first of all, to verify whether you have kit version installed, you can just use kit version, and that shows you the current version of your kit CLI. And now let's basically proceed further. So now I will use kit login to basically log in to my kit, and here you will basically provide the details of what is the registry that you're using. So in this case, I'm going to be using Zozo Hub, which is a really specialized registry for being able to store your model kits. And here I just put my username and password, and once I've logged in, now I can start to manage, like this is very similar to like a Docker Hub sign-in that you have to do when you're using the Docker CLI. So here you can see that I have this example of a Zozo Hub model kit that has been hosted on Zozo Hub, which is this YOLO V10. I can very easily now go ahead and actually use the pull tag, or I can do kit unpack and give the name of this particular registry. In this case, you can see that this particular model kit has the model, the docs, and the configuration files which are available. So in order to basically create, what I'll use is the kit unpack command. Now, of course, I can do it in this particular registry. Here, what you are seeing is that the kit unpack zozo.ml is, of course, where this model kit is being deployed. And then I give the name as the name of the owner and the name of the repository. So name of the owner is Zozo, and then the repository name is YOLO V10, and then the V10x is the tag. So I'm just creating this new repo locally, and then this is where I'll unpack it. Now, as soon as I unpack, you'll see that it will unpack all of the different components of the model kit that had been used to store, which is like very similar to like we have layers in a Docker image. So these can be thought of like as different layers. So it is unpacking all of these different files right now. as soon as it basically does that, if I take a look at my list of the model of the files, you can see that it has the kit file, the readme, the model itself, like in the tensors format. And if I see the model kit itself, you can see the kit file over here, which shows me the manifest file, the package details, then the model details. So in this case, it's the safe tensors and it's the YOLO V10 model. And I have my docs, which has the readme file. So this shows all of the details about my kit file. Now what I can do is that I can actually use this same kit file to now package a new model kit that I can store locally. So for that, you can see that the kit list, like a Docker list, shows you the list of all of the model kits that you have locally stored right now. So the one that I just recently downloaded, you'll be able to also see those. Now, if I want to create a new model kit, I can use the command kit pack, right? So I'll use the command kit pack, and I will give it the details where exactly have I stored my kit file. So dot means that it's in the same directory. Then I use the -t command, and then I provide it the name. So in this case, because I'll be publishing this on Zozo ML, I just give it the name, and then I will give it the name of the user where I'll be uploading it. So like that is Shivai Lamba in my case, because that's my name on Zozo Hub. And then I'll give it a new name. So this is the name of the model kit with a tag that I'll give to it. And you'll see that it basically packs the different layers from the kit file. So different layers are the model, the data set, and you can see that it just created that particular model kit. Now, in order to actually upload it, I will have to also create a repository name, and we'll keep it as the same name as our model kit so that it matches when we push it to this remote registry. And now once I've created that particular repository on Zozo Hub, I can now use the kit push command and again provide the model kit that's stored locally in my system. So that's Shivai Lamba, and this will upload it to the repository YOLO v3 that we have pushed online. So as you can see, like it's starting to push it to this repository. So just ensure that that name of the model kit locally and the repository in your Zozo Hub registry matches, or for that matter any other registry. So you can see, like, again it pushes this layer by layer. And one thing to keep in note is that when you basically also use like the kit unpack command, you can do selective download of different components, because as I said that there are different components, the dataset, the model, all of those are separate. So if you just want, like, let's say the data scientist does not want to download the actual original model, they just want to download the dataset. So I can selectively say that by giving the filter, by giving the flag that filter, I just want the dataset and the model instead of download all the things. So this way, like in case multiple teams are using the same model kit, you don't need to download every time all the things. Like only if they need some specific parts of the model kit, they can do that. So that's the great part about like resharing this model kit across the different team members that you will have in your team. So by using that particular filter, that allows you to very easily just manage specific parts. And now you'll see that when I go back into Zozo Hub, I would have uploaded it successfully. Now you can see some of the most popular repositories, including the ones that are signed. So this basically tells you that these are properly, security tested, and these are signed. So these are properly authenticated as well. So you can apply those type of security measures when you're uploading your model kits to the registry. In this case, like you can see, like it has successfully, uploaded it. So that's a quick overview of the kit file and what basically the kit file looks like. Now, of course, one important aspect is that how can we automate the machine learning lifecycle with the help of CI/CD? Because as we know that CI/CD is an important aspect for us not having to manually, like every time we push some code, having to test it and rerun our pipelines each and every time. So that's where the CI/CD really works. And the similar is the case for machine learning as well. So like imagine that whenever you're trying to push a machine learning model to production with a new version, so you push the code, then you generate the new dependencies, or for example the model files that could be a H5 format or a pickle format, and manually having to then deploy it where you are running it in production. So all these steps can be automated with the help of CI/CD. So You can also then add GitOps as part of your CI/CD pipeline to automate the deployment of these AI models, which can be triggered either manually or automatically based on, like, let's say, the changes that are taking place in your model or the artifacts. So this means that GitOps not only helps you to simplify the packaging of the models, but by leveraging it with the help of CI/CD, you also automate the deployment of the AI models and not have to make it, something that you have to do manually each and every time. So you can trigger these deployments and truly streamline the model lifecycle management by defining your own way in which how you want new versions of the model or your entire model pipeline to look like. So you can very easily then adopt GitOps with GitHub Actions, Jenkins. In fact, like, you'll find a lot of different resources to use it in conjunction with your CI/CD tool of choice. And here's like an example of how you can use it with a Dagger CI/CD. So you install GitOps, you have Dagger IO installed, and here you'll see that, what we are doing is that you create your file, you run your Dagger pipeline, and based on the Dagger pipeline, what would happen is that, like, once you have created the model kit with the kit file, you initialize your Dagger module, and then you Daggerize your kit file. And then when you define your pipeline functions, and then you can, integrate your Dagger module with a CI/CD, that could be an example of a GitHub action. So whenever you are pushing some new changes to your kit file, it will instantiate your Dagger module, and then that basically goes ahead and kicks off your CI/CD workflow pipeline that's running in GitHub Actions, and then you can automate the deployment of your latest changes to your kit file or to your model kit to the registry. In that case, that could be a Zozo Hub. So this is an example, like a typical example of how it would look like. In case you had Jenkins, it would look like something like similar, where you define your Jenkins pipeline, you define your model kit behavior when you want it actually to kick off the Jenkins pipeline. So you can define all of that in your configuration. So of course, MLOps is also a really important aspect, and you can really instantiate that with the help of model kits. So whether you're using your machine learning models for training, experimentation, that's where you need the ability to package and validate your model deployments. And even then, you can use your model kit as inference, because you can technically go ahead and leverage the model kit that you have deployed on Zozo Hub. Like, let's say you can run it as a container image, or you can deploy it on Kubernetes as an init container, or as a kit file or kit CLI, right? So you can basically do experimentation, because, like, let's say that you have defined a model kit. Now you could have different versions of the model kit. You can store them as different tags and upload them. So now you can very easily see the differences between the different versions or the tags based on experimentation and the changes that you had to make to your model. And then you can very easily understand all of them and do experimentation as well with the help of model kits and having the different versions that you will have, right? So this makes training, experimentation very easy. And then inference, you can deploy your model kit as an inference service with the help of and on top of, like, different type of modern day cloud platforms like Kubernetes or Docker. And as I mentioned, that you can deploy these model kits by either creating a container or a Kubernetes deployment. So it could either be an init container or a kit CLI, which is a highly specialized containerized kit CLI that will be used to tailor the running of the model kit, because you can basically run the kit CLI command. Or if you don't want to do that, you can just use an init container, which is like a default way to basically then run it inside of a Kubernetes based environment. So those are readily available to all of you. These are some of the resources that you can check out. So you can check out GitOps on gitops.ml. You can take a look at the documentation. You can take a look at the dev.to blogs, which show how you can integrate with CI/CD tools, with different kind of MLOps tools. And another thing is that, as I mentioned earlier, that we are looking at a wave where we went from the storage to the VMs to our containers, and now we're looking at models. So we are proactively having discussions on the model spec discussion on the CNCF Slack, and here is a Google Doc that actively takes part in that. So the primary target here is that we want to make AI models as first-class citizens. So we want to proactively make some changes to our OCI spec that is better well suited for machine learning based models. With that, thank you so much for attending. You can scan this QR code for these slides, and you can also connect with me, and you can join the GitOps Discord, which is again an open source project that will lead you to have discussions around GitOps, and of course you can connect with me on how to develop. So thank you so much for watching this video, and I hope you have a wonderful time watching the rest of the amazing talks at the conference.
Next up, we have Kaz, who is going to be talking about building AI agents for e-commerce with ADK plus vector search. Kaz, the stage is yours.
Hi, thank you for taking your time for my session. It's titled Build AI Agents for E-commerce with ADK and Vector Search. I'm Kaz Sato, developer advocate for Cloud AI team. I'm based in Tokyo. In these sessions, I'd like to discuss how you can improve the user experience of the generative AI applications by introducing the AI agent technology. Let's first think about the typical RAG systems, the RAG for the retrieval augment generation. So for example, the user may ask questions like, can you find Google Pixel 9? Then your LLM like Gemini will take that. Sure, I will use the vector search to find the Google Pixel 9. And the LLM issue a query to the backend where you would have the vector search backend that retrieves the item information or documents. That's how it works. But there are some challenges if you want to bring the RAG system into productions. For example, especially for the e-commerce use cases, it's really important to have the multimodal search capability and also keyword search capability. So for example, the user may ask, can you find cups with dancing figures? The product number is 123 ABC. The actually typical retrieval engine, vector search similarity search engine doesn't work for that. Because the similarity search is not designed to do the keyword search or multimodal search usually. Another challenge is the recommendations. So if you provide the RAG system to the end user, then the expectation is that, oh, maybe the GenAI app is so smart so that it can take any vague request or the ambiguous request, and they can solve their problem. But actually, as long as you are using the usual retrieval systems like a similarity search, it doesn't have any recommendation functionality. So before diving deeper into the AI agent, I'd like to first discuss what are the advanced practices you have to introduce to the vector search backend of the RAG systems. Here I'd like to discuss the three different techniques. One is the multimodal search, the second is hybrid search, and the third is task type embedding. Let's start with the multimodal search. So in the typical RAG systems, you'll be using the text embedding model. By using that, you can find the text with the similar meanings on the vector search. There are new types of the embedding model called the multimodal embedding model that allows you to generate the embeddings for the images and text. And the thing is, the similar meanings on both text or the images result in a closer embedding distances in the entire embedding space. So this enables the text to image search or image to text searches. And in the past, you have to design your own deep learning model or vision language model to generate the multimodal embeddings. But now it gets super easy. You can get the multimodal embeddings by using the Vertex AI Embeddings API. The next topic is the hybrid search. The semantic search is limited to the what embeddings model understands. That means if the user asks with the some product numbers or newly added product names that didn't exist when the embedding model is trained, then your vector search similarity search doesn't work for finding the items. This limitation can be a major issue when you are bringing the RAG system into production. So the hybrid search addresses this problem by combining both semantic search with the keyword search, or so-called sparse embedding, into a single vector search index. So that allows you to have the single query running against the vector search to retrieve the both results, keyword search result and semantic search result. So this is a demo built with the Vertex AI Vector Search where you can try the multimodal search in action. and it has the 3 million actual real-world retail items that is provided by the Mercari.com, which is a popular setting app. So let's start with the query like cups with dancing people and submit it. Then from the 3 million items, you can get the result instantly like this. And please note that the items were found searched only by looking at those images. So this demo doesn't looking at the any items titles or descriptions. So the multimodal embedding model is looking at those images and understand what's happening in those images. These are all cups, and there are dancing figures, dancing people on those cups. So that even without using any the categories or tags or any metadata, you can make any arbitrary multimodal search like cups with Google logo colors. So you can find those cups. So apparently the multimodal model understands what are the Google logo colors and what cups have the Google logo colors in those images. Now let's try the hybrid search. So by typing any keyword search query like 1, 2, 3, 4, usually this kind of query doesn't work for the semantic similarity search because the query doesn't have any meaning. But with the hybrid search, you can get the result where the descriptions or the item names has the specified keyword. So what you get is the mixture of the both similarity search and keyword search. The third topic is the task type embeddings. And what is the challenges it can solve? The problem is that in many cases, the user would ask a query like, for example, why is the sky blue? But in many cases, the answer for that question, like a scattering of air, has the quite different semantics to the query. So question and answers in many cases are not semantically similar. So that's the reason why sometimes the similarity search doesn't work for that kind of query. So instead of finding the similar text, you have to find a relevant text to the query. So over 10 years, the professionals and the researchers for the information retrieval had been addressing this problem by designing a special deep learning model called the dual encoder model, or also called the two-tower model, as it has the two towers inside a single model. With this dual encoder model, you can train the model so that the model can learn the relationship between the query text and the document text, rather than just finding the documents by the similarity. But it wasn't easy to design and build your own dual encoder by yourself. You had to hire a bunch of the data scientists and ML engineers. But now it's got super easy to get the benefit of the dual encoder by using the Vertex AI Embeddings API. Vertex AI Embeddings API provides the embedding called task type embeddings that provides the pre-trained two-tower model, dual encoder model inside it. So the question embeddings and answer embeddings will get together, will get closer in the entire embedding space, so that you can easily find the relevant the result rather than similar results. Now let's try the task type embeddings with this demo. So at first, I'd like to make a query by using the usual semantic similar search with the vector search for the queries like birthday present for my son. Then you would get the result like this. you are seeing many keychains, key links, but because these products has the similar descriptions, like the birthday or family or son, but maybe these are not the best birthday present for your son. So instead of the semantic similarity search, you can switch to the task type embedding specific for the question and answering type tasks. And using the same query and same dataset and submit the query. Then now you get the much better search results. Because the task type embedding model knows what are the relevant or suitable result the user would be expecting. Like Lego sets could be a great, Spider-Man boy's gift could be a great gift for their birthday. So the model understands that. So this is how you make the recommendation to the customer. Now we have covered how the advanced practices for vector search can solve the common issues for the typical RAG systems. Now let's see how the AI agent technology can improve the user experience further. Let's consider another challenge, smart recommendations. Here user would ask, can you suggest birthday present for my son? What's the latest trends? The LLM receives this request and wonders, how do I make a smart recommendation with the latest trends? This question requires more than just finding a specific items. It demands understanding the context, like what's the latest trends? And make a personalized suggestions, which can be difficult for the traditional retrieval systems, even with the advanced practices of the vector search. This highlights the need for a more sophisticated approach to handle personalized, trend-aware recommendation. The solution is using AI agents combined with the vector search. The UI agent can take the user query and triggers the Google search at first to make a research on the latest trends. Then generate a bunch of queries for finding the interesting items and asking the search agent to search them. The search agent takes this request and starts generating a related, more specific queries like STEM toys for age 10 or science kits for 10 years old boy or experiments for 10 years old boy. These queries are then passed to vector search, which can provide a much broader and relevant set of results. This multi-agent approach allows a more intelligent, multifaceted search strategy, going beyond simple keyword matching to provide a truly helpful smart recommendations. This is a demonstration called Shopper's Concierge built with ADK and vector search. So it has the capability of the live voice communication, so let's try that.
Hello, I'm Shopper's Concierge, an AI agent. This e-commerce site has about 10 million items. What can I help you with today?
Can you find cups with dancing people?
Here are the cups with dancing people. You can refine or change the search or start a deep research. The mug features dancing skeletons in ballet poses with "Dance Like Nobody Is Watching" printed inside. It's 18 ounces, ceramic, and hand wash only.
Now let's try the image-based search because the AI agent can understand the image as well, so you can upload your own images.
I see a desk with a laptop and a black office chair. Here are the search results for desk organizers and monitor stands. You can refine or change the search or start a deep research.
So you notice that the agent is not just doing the image similarity search. Rather, it understands the context and the intent of what it is seeing in the image and try to suggest relevant, interesting items to the user. And if we pick one of them, like this one.
This adjustable dual monitor stand from HUANUO fits 13 to 30-inch screens using a spring desk mount with swivel VESA bracket and holds 4.4 to 19.8 pounds per arm.
As you can see, because the Gemini can also generate an image, it can show how the images can look like when you put the items on your the home office. Now let's try the deep research mode. Can you find a birthday present for 10 years old son by using deep research?
I will use Google search to research popular birthday presents for a 10-year-old son. Is it okay to start?
Yes, please.
Okay, here are some featured items in STEM building kits. LEGO Boost Creative Toolbox Snap Circuits Jr., SC100 Electronics Discovery Kit, and TEMS and Cosmos Kids First Coding and Robotics.
As you can see, the behind the scene it generates the 20 queries for each item categories, up to 100 queries for a single deep research request.
Great. Is there anything else I can help you with?
And after the deep research, the concierge picks the best items it found with the deep research. Let's examine how this demo was constructed. I have used the ADK, Agent Development Kit, that is an open source framework for building an AI agent developed by Google. And that was announced at the last Next 25, happened in the last April. ADK is a framework for the multi-agent based the GenAI app. And it's not only supporting the Gemini, it also supports the third-party models like Llama. And it also supports the live audio and image streaming in real time, though you can provide a much better user experience like the actual human super concierge. And here's how the deep research mode works with the ADK and vector search. The UI agent initially uses Google search to learn what is the trend for buying the birthday present for 10 years old son, and understand the user intent and the latest trends. Then the UI agent asks the search agent to generate 20 queries per categories. The agent repeats this for 5 item categories, total 100 queries for a single deep research request. All queries use multimodal embeddings, task type embeddings, and keyword embeddings. And those 100 queries are sent to vector search running in parallel. The search agent also performs so-called multimodal item curation. It reviews item images and descriptions one by one. In the multimodal item curation, the demo generates an image tile like this under the hood. This image tile with the all items and also the description of the all items are passed to Gemini as a prompt. So we let the Gemini choose which items are the most relevant and valuable items for the user. Let's summarize the benefit of the AI agent integration with vector search. It enables multimodal, multi-agent search with real-time user interaction. And so-called generative recommendation with the AI agent understand user intent and create tens of the query in a single request. And the vector search ensures the high quality and low latency and scalability, efficiently handles numeral parallel queries. So if you are interested in these solutions, please take a look at these documents. There are 2 documents. One is the vector search documentation where you can find all the getting started or tutorials, notebooks, and blog posts. Another document is the ADK documentations where you can find the getting started and tutorials for the ADK and sample codes. So that was my session. Thank you so much.
Next up, we have a really, really interesting and interactive session here. I'm not going to butcher the Irish language by trying to pronounce this. I'll let Rudy do that himself in a second. But in English, it is the artificial storyteller. Rudy, the stage is yours.
Hi everyone and welcome to AI Crush, although I'm sure you've been here for a little while already. My name is Rudy O'Reilly Meehan. I'm the founder of Data and Design, a data visualization studio that I'll talk about in a moment. And I'm here to show you the results of my latest AI experiments, which I'm calling An Seanachí Saorga, or the artificial storyteller. You might be familiar with the Irish language, you might not be, but strap in for a 20 to 25 minute tour de force of all things AI, Irish mythology, Irish language, and data visualization. So let me talk to you a little bit first about me. This first section is called Data Dríocht, or which means data magic. And I run a studio called Data and Design. I use data visualization and storytelling to bring data to life. So I create these pieces which are often interactive. On the left-hand side, you can see a piece I created for Kildare County Council in Ireland called Unravelled. This is for an exhibition that combined elements of storytelling with woven fabric. And I created this piece called Unravelled, which explored the emissions of the town of Maynooth through the means of an embroidery circle. So these are the types of pieces that I create. And I do love creating pieces based on open Irish data. For example, a recent project of mine was called Snakes and Landlords. And this piece, I explored open data on evictions in Ireland to kind of create this playful storytelling piece in which you control this cat with your finger or mouse and uncover these different illegal evictions that have happened in Ireland over the last 10 years. And I was inspired for this by the Snake mobile game. And what you'll see in a moment is a snake starts coming in and eating these houses, evicting these tenants. And this is the means to explore this data, but we've also got some pretty fun, playful interactions here. So for example, in a moment, I'm going to channel my inner St. Patrick and try and capture this snake. And now that I've caught this snake, we can do a merry dance. And finally, I can banish this snake from Ireland, just like St. Patrick allegedly did all those years ago. So in creating these pieces, I have a unique kind of Frankenstein tech stack where I will use Python to analyze the data and then create these interactive websites, mainly using a combination of SvelteKit and D3.js. And a huge part of my work is not only working with clients to explore and bring their data to life, but is also trying to become an advocate for stronger Irish open data and telling stories with that data. Of course, like all of us, I would have dabbled in AI. I was really only an AI hobbyist until about 2023, when I had the opportunity to collaborate with OpenAI on an itinerary generator for Dublin. So this is a piece called A Day in Dublin. It was based off OpenAI's tech demo, which they called Wanderlust. And the idea is that you would chat with this chatbot, put in your preferences and what it is you were doing, and it would match different activities with you. The demo they created, Wanderlust, had a few extra things in it, like PDF ingestion and things like this. But we kind of took that out for A Day in Dublin. And working with OpenAI was fantastic. I was able to look at some of their newest APIs. So this would have been, 2023. So things have moved on incredibly quickly since then. But as I started working on this project and trying to match people with different activities, restaurants, and events in Ireland, I kind of started realizing something. And I realized there was a vibe. And in Irish, the word vibe means a problem. And a big problem I had in trying to build this demo, A Day in Dublin, was that these AI models seem to struggle with the concept of Irishness. It's a very ethereal concept, but anyone who's Irish knows when it's not quite right. The same as when you hear an actor trying to do an Irish accent and getting it wrong. For example, I found that what I'm going to call vanilla versions of ChatGPT were recommending kind of vanilla activities. So, for example, anyone who's been to Dublin, it was recommending people to go to Guinness Storehouse and then go to Temple Bar and then go to Trinity College to check out the Book of Kells. There's nothing wrong with that per se, but what we wanted to do was try and create real recommendations that you would actually get from Irish people and not just the most popular tourist attractions in the world. So the way I was able to get around this vibe or get around this problem for a day in Dublin was to enrich those models with thousands of Irish activities, events and businesses. So by providing all of this local Irish data to these models, we could create something that could create these bespoke experiences around this. So on the left-hand side, you can see somebody who's interested in hiking, water sports, seafood and music. And it's created this itinerary for them. And it's also come up with a funny name for it. Although I have found thus far that AI's idea of funny is usually just alliteration. Luckily, we've been spared the alliteration in this case. But what I really enjoyed in this project was trying to almost wrangle these AI models to understand what it means to be Irish. And I started thinking to myself, could this approach work elsewhere? So that's where I started to have the most dangerous things of all, which is ideas. I've always had this fascination with Irish storytelling and this concept of the Shanachie. So in Irish storyteller, the Shanachie kind of sits as this oral repository. They are a person who passes down information from generation to generation. And we've got all this incredible old Irish mythology stories. And these are epics. These are kind of akin to those Greek epics, things like Fionn and Fianna, and the epic battles, betrayals, and characters of these era. And we have these stories were being spread orally through these Shanachie, and these Shanachie, started with people who were employed by the wealthy, but then it almost turned into this underground network of secret storytellers as Irish was under British rule into the mid 1600s. So I've always been fascinated by this idea of the Shanachie and telling Irish stories. So it got me thinking, what could an artificial storyteller look like? And that's where the name An Shanachie Saorga comes from. The Saorga means an artificial storyteller. And the real test here is I'm not for a moment trying to replace the incredible, rich stories that we have here in Ireland. What I'm trying to do instead is try to experiment around to see, can AI capture that ethereal concept that is Irishness? Can we enrich these models with our own Irish data to create things that aren't twee or aren't, your leprechauns and Paddy and stuff like that, but instead capture the epic nature of these stories? So that's where the real concept for An Shanachie Saorga came from. So as I kind of fleshed out this idea, I started to try to think, okay, what could an Irish storyteller do? Well, we could tell immersive Irish stories using AI. We could bring in multimodalities. So, for example, we wouldn't be reliant on text only. Shanachie was a spoken word. A lot of these stories were never written down, which means that a lot of stories have different endings and different versions depending on who it was told it. And by incorporating AI into these stories, we also allow for dynamic storytelling. We don't need to just give people static information, but rather we can deliver dynamic stories that kind of change as the user starts to make different choices. So these were some of the ideas that I decided to bring in to the Shanachie. So the next question is, what stories should we look at? Well, thankfully, with our rich tradition of oral storytelling in Ireland, we have no lack of stories. What I decided to focus on was the Fenian cycle, and this is one of the most famous cycles of Irish storytelling. Within this, we focus on the mythical hero Fionn McCool and the Fianna, who are his warrior band. And there are stories about their exploits, their battles, their rivalries, the different characters, magic. And these date from as early as the 7th century and continue all the way up to the 19th and 20th century. So these were the stories that I decided to use for this Shanachie. as I started looking at the material over and over, a thought started coming to me. You see, when I started creating this Shanachie, I wanted to create something that was truly choose your own adventure. I'm in my mid-30s. When I was growing up, everybody was obsessed with the Goosebumps books. So again, if there's some younger people on the call scratching their heads, bear with me for a moment. But these Goosebump books had these kind of, some of them were these choose your own adventures. So, you'd turn to page 14 and it would say, if yes, go to page 38. If no, go to page 41, for example. And you would flip through this book going this way. Sometimes going down blind alleys, sometimes approaching a real ending. And initially, I'd wanted this Shanachie to follow a similar structure, to be truly open-ended and immersive and let the user plot their own story. But a funny thing happened. As I started reading more and more and more of the material, I started thinking, well, this is great and having that choice is amazing, but these are incredible stories here that deserve to be retold, not replaced. And that was where I kind of created this guiding principle for this piece. That at least in this iteration, we've got so many dozens of incredible stories. Let's try and tell these stories. We can reimagine these stories, introduce choice into these stories, but not replace them. So that kind of, actually gave me constraints. But as most designers know, constraints when it comes to these types of projects can often be good things. So let's get into the nitty-gritty of it. We're going to use a few different agents in order to kind of build this Shanachie. So the first thing we're going to do is we're going to start with our text corpus. So this is over 200 public domain stories from the Fionn folklore database. So these stories are so old they're in the public domain already. And we can see an example of such a story on the left-hand side. We've got the Irish name, the name, and the story. And in this particular story, Fionn McCool is aboard a ship, and in different, you might notice if you're reading it, different versions of the stories have different attributes. And in this particular story, a storm arises, and they begin to fear that the ship will sink and they will all be drowned. So these are the kind of story that would be typical of Fionn and the Fianna. So what can we do with this? There's a few things that we can do. The first thing we can do is we can run some named entity recognition to extract all the characters and locations from these stories. So we'll need these for a few reasons. But for now, you can see down the bottom of this screen on the left-hand side, we can see we've captured the three main characters of the story, Fionn McCool, Lum McLeaven, and Duan's daughter. So the first thing we do is take this story, and from it, extract the different characters. The next thing is that we turn the task of creating the Shanachie over to two different agents. The first is our scriptwriter agent or screenplay agent. And what this agent does is they use the Anthropic API to take that story that we saw on the previous slide and turn it into multiple scenes, trigger points, and choices. Very much the same way as a screenplay writer or scriptwriter would do for a movie. So let me show you an example. Based on that earlier guiding principle, like I said, we're not trying to completely alter the story. Instead, what we do is we can create different scenes within that story and then have different choices that the user can take and triggers based on those choices. So for example, for the scene that you just saw there, our setting is now on board a ship in the midst of a fierce storm. The action is that the ship is caught in a violent storm and the crew fears it will sink. We've got three different choices, either following through with the suggestion, proposing an alternate solution, or confronting the person asking you to do this. And then the scriptwriter also pulls out these potential triggers that can happen next. So like I said, I want to give people this choice while still having this almost Goldilocks effect where we want to make sure that we're still staying true to these stories, because thinking about this essence of Irishness that we're trying to capture, if Fionn McCool suddenly turns into a magical octopus and jumps off the ship, this can very much break with our immersion. So it's through these choices and triggers, through our scriptwriter agent, is how we kind of balance that kind of problem. And later on, I'm going to share a QR code to the GitHub repo where all of the different prompts for these different agents are also online. The second task we ask our scriptwriter to do is to come up with a database of characters and their motivations. So we're going to need this for the next bit. So what we can do is we can ask our scriptwriter to look over all the stories, and from that, and from its own understanding, build up a kind of a description of each character. And really the description that we're interested in here is more so around the character's motivations. So for example, we can see on the top one here on the left hand side, we've got Fionn McCool, who is assertive, yet can lead to friction and discord within his ranks. So again, these character motivations will come in useful in the next bit when we're creating our scene. The eagle-eyed of you might also notice that we've got this phonetic name where the names are spelled in quite a funny way, and we'll come back to that in a moment. So our scriptwriter turns our script into different scenes, and we create a database of different characters. Next, it turns on to our director agent. So this agent is tasked with describing the scene created by the screenplay writer. So here's an example of the prompt that I would give to this director. So the director is given the screenplay for the scene, including characters and the motivations. You can notice how I have had to be very direct with Claude in asking it to avoid Irish cliches, be extremely sparse in its language, be short, be concise. Now, below I speak of the characters. Again, I've just truncated it here just so it all fits on the one slide. We've got the setting and we've got the action. The last thing I want to mention on this slide is that this could be done live. Again, the earlier version of this I created was using the Anthropic API live within SvelteKit and generating the text that way. However, I've decided to pre-render this for the demo that you'll be seeing because of the cost of the following two steps. So one thing I haven't mentioned is the number of stories. So we have about 105 different stories, and each of those stories has 10 different scenes depending on the different options the user takes. Again, this is all fine to render with the Anthropic API, but it's the following two steps which means that I actually pre-render everything in order to save money. The first is around the text-to-speech. So I use 11 Labs Flash 2.5 model and their Irish voice Neil. It's kind of a Northern Irish voice to narrate these scenes. Neil works pretty well, but does tend to struggle with place names and character names. And that's where you saw the phonetic names earlier on. So we match the names with those phonetic names in order to help Neil try and approximate them better. Because again, we're trying to find ways to, avoid breaking that immersion. And finally, we use OpenAI's image generation to create the images corresponding to each scene. So the OpenAI image generation has gone very viral recently. Luckily for me, the API only released last week, so I didn't have to spend over a few nights keep generating these images. So luckily I was able to pre-render a lot of these images that we see here. And again, here's the prompt on the left hand side for what I was using for those. So now we've got our script written. We've now got the scenes created by our director. Our character name, the scenes go to 11 Labs, and the OpenAI API generates the images. So now you're going to get a chance to see the Shanachi in action. I'm going to run this quick demo on my side, but this QR code on the left-hand side will lead you to the demo where you can try it out for yourself. I'm just going to stop sharing for a moment and share my tab instead. Okay, and here we go.
The night crept cold around Fionn McCool's dwelling as embers cast long shadows across stone walls. Cuil Te and Far Srini Na Rov sat close to the fire while their leader stood by the narrow window, watching stars wheel overhead. A knock disturbed their quiet talk, and Fionn McCool opened the door to find a stooped woman with eyes like winter pools. "I seek shelter from the night's chill," she rasped, her cloak too thin for such weather. Cuil Te rose swiftly, sensing something ancient in her bearing, while Far Srini Na Rov whispered, "The Kyloch takes many forms. Remember the tales." Fionn McCool studied her without speaking, his thumb pressed to the tooth of wisdom.
So we can see here it's generated that scene, and we've got different interactions below based on what the user wants to do. So for example, I might refuse a request and ask her to leave.
The gatepost still creaked where Fionn McCool had turned the old woman away. "The quaich is gone," he growled, tracing the frost-rimmed footprints leading into the dawn-lit woods. "The Kyloch has played us for fools." Cuil Te knelt to examine the tracks while Far Srini Na Rov fumbled with his belt knife, shame burning his cheeks. "She knew our weakness was pride," said Fionn McCool, his voice cutting through the morning mist. "Swift feet may yet redeem slow wits, Cuil Te." The fleet warrior nodded grimly, already scanning the tree line. Far Srini Na Rov stepped forward, hand on his sword hilt. "The oars I mishandle, but a trail I can follow." Fionn McCool looked to the lightening sky. "Then let us hunt."
Okay, so that was the couple of screens from the demo. I encourage you to play it out yourself and come onto this link. When you go onto this link, you won't be able to just pick this story, but rather 100 different stories of that time from Fionn and the Fianna. In terms of the piece itself, I think as a piece of art, as a piece of technical experimentation, I'm very happy with it. If you listened to the narration, you would have noticed there was a few times where it kind of approximates those Irish names and slightly jars, slightly breaks from the immersion. But as a first pass, I think it's really interesting. And what I noticed was that, similar to my project with OpenAI, that to get these models approximating that ethereal thing that is Irishness, you do have to kind of put your thumb on the scale. These models aren't being created for Ireland, and until we have a large language model that understands the Irish language itself, we're going to be resorted to tricks like this. If you have any questions around the project or visualizing data more broadly, please connect here. So this is my LinkedIn. And like I promised earlier, there's also a GitHub repo link. So this is the GitHub where the project is. This project was created by me, Rudy, and I am the founder and CEO of Data and Design. And this project was funded by Naptha AI. So I'd also like to thank Niall for having me here at AI Crush. I'll probably be in the chat fielding questions, but otherwise the main way to get in contact with me is, like I said, through LinkedIn here. So thank you very much, and I wish you all the best on your adventures through the Shanachie.
Wires inside my heart, they tangle. Circuits burning up in your angle. Zeros and ones, they set the fire. You're my digital desire. Bleep, bloop, beep, my heart's in code. You got me in overload. Electric love, can't turn it off. You're my AI crush, let's reset the clock. Binary love notes in my inbox. Robotic feelings they unbox. Every bite of you is pure delight in a virtual late night. Bleep, bloop, beep, my heart's in code. You got me in overload. Electric love, Thank you.